Uh, so let's first uh, move on to maths. Okay. So last time we did finish relations and functions. I want to do some past paper questions on relations and functions, but I thought because now we are almost at the end of the syllabus, so let's finish the syllabus and straight away do the past papers. Okay. So then it's easier for right. Right. So therefore today we want to start uh, techniques of counting. That is the smallest topic you have, and we can finish it right within 1.5 hours. Okay. Techniques of counting. Again, the note is available in the Google Classroom under maths, techniques of counting. So let's go through the note. Okay. Right. So techniques of counting is a separate topic. Uh, so those who have done A-level maths definitely have done this topic. But if you haven't done A-level maths, maybe this completely new topic for you. But so this topic is where you need to understand the concept. You don't have to do much of a calculations and nothing like that. Just you need to understand the concept, and straight away, if you have understood the concept, you can straight away write the answer. Okay, so that is a type of subtopic. Okay, and this topic is very important to understand some other topics and your IQ levels as well, because it's IQ is all about understanding patterns and so on. So this is also sort of a understanding patterns. Okay, and also this understanding this topic is very important for your probability subject as well, right? So if you want to understand probability proper way, first try to understand this topic. Okay, techniques of counting, right? So so this topic we can subdivide into two, that is permutations and combinations, sankarnasa samyojana, right? So permutation means how many ways we can arrange things. Say, for example, if I have three letters A, B, C, I can arrange like this. I can arrange like A, C, B, B, C, A linearly. Maybe I can arrange circularly like this. So permutation is all about arranging things linearly or circularly. Those are the two we look at in your syllabus. How many ways we can arrange linearly, how many ways you can arrange circularly. So that is permutation. Okay. So then your second part is combinations. How many ways you can select things? How many ways you can select things? For example, say we have three people, X, Y, and Z. Say we want to select a committee of two. Committee of two. So what are the possible number of committees? Here, there's nothing called arranging, right? So we just select, we don't care who is the first one. Maybe you can select X and Y as a committee. X and Z as a committee, Y and Z as a committee. So that is called combinations, right? So therefore, these are two different concepts. Permutation means how many ways or different ways you arrange. Combination means different ways you select. Okay, of course, based on conditions. Okay, so that is what we are going to look at in this topic. So linear arrangement means you arrange it in linear way, like this. It's a line. Circular arrangement means you arrange like in a circle. So anyway, we look at those things, right, later. Right. So that is what we are going to do, right? Permutations, combinations. Permutations means how many ways we can arrange. Combination means how many ways we can select. Right. So before moving to permutation and combination, first we need to familiarize with factorial notation. Of course, you guys are familiarized with factorial notation, right? Familiar with factorial notation. Because a lot of these at number of arrangements, number of combinations, questions, their formulas involve factorials. So what is factorial? So factorial of 5 is 5 into 4 into 3 into 2 into 1. Right? We discussed that in programming also when we discussed recursion in semester 1. So factorial of 3 is 3 into 2 into 1. Factorial of 2 is 2 into 1, and obviously factorial 1 is 1. And by definition, factorial 0 is also 1. That is a special case. Okay. So therefore, what is factorial n? So factorial 5 is 5, 4, 3, 2, 1. Then factorial n is n into n minus 1 into n minus 2 into until you get 1. And that multiplication. Right? And factorial is defined only for positive numbers and 0. Positive whole numbers. There's nothing called factorial 1.5. Factorial minus 3. It's only for natural numbers or positive integers and 0. So factorial 0 is a very special case. It is 1. Okay, it is 1. So then obviously you must ask a question. If you are a logical thinker, do you have any question if you are a logical thinker? Anyone? If there's at least one logical thinker here, you must ask question now. Of course, if none of you guys are logical thinkers, critical thinkers, none of you guys will ask that question. But I hope at least one of you is a critical thinker. So from what I explained so far, do you have any question that you are not still happy as a critical thinker? Like when do we need to use factorial? We'll discuss. So that is what we are going to do next. Yes. So that is the critical thinker's question. So when someone says factorial 0 is 1, you must ask why. Is it coming from heaven? Is it God's words? Okay. So why factorial 0 is 0? Why is it factorial 0 is 1? Right. I'll explain why factorial 0 is taken as 1, because in practical situations, we need to take it as 1 so that the reality and maths is sort of complying with each other. Right. So later I will explain why factorial 0 is 1. Okay. But I hope you can understand the factorial notation, right? So why it's just a notation. It's just a notation, right? Standard. Just like we say x to the power of y is x into x into x into y times. So people can come up with notations. And also make sure you notice that factorial 5 is 5 into 4 into 3 into 2 into 1. And if you look at this closely, this is factorial 4. So therefore, you can write factorial 5 is 5 into factorial 4. And so likewise, factorial 8 is 8 into factorial 7. And in general, factorial n is n into factorial n minus 1. So those are important observations that you need to take when it comes to factorial. Actually, that is why we can write this in a recursive manner, right? Write a program in recursively, because factorial n is n into factorial n minus 1. Remember we discussed this in programming? Right. Other thing is, when you are asked to simplify factorial related things, for example, if someone asks what is factorial 8, of course you need to write 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1 and multiply. Then if you are given something like this, say factorial 8 divided by factorial 5. So this is very easy. Don't multiply all these things, because this is 8 into 7 into 6 into, then 5 into 4 into 3 into 3 is factorial 5 divided by factorial 5. So you can simplify, and just the final answer is 8 into 7 into 6. If someone asks what is the factorial 109 divided by factorial 107, so the simple answer is 109 into 108. That's it, because rest of the stuff get cancelled. So just keep those things in mind. Otherwise, you will simplify. Right. So now I hope you have a reasonable understanding about factorial notation other than the open question of why is it factorial 0 is taken as 1. Okay. Right. So this is the notation we use, exclamation mark. Okay, exclamation mark. Now we'll move on to permutations. Right, permutation. So permutation is all about arranging things. Arranging things. Okay. So we are interested in how many ways we can arrange. So total number of ways we can arrange. Okay. And you can arrange in different ways, right? We can arrange like this, we can arrange like this, we can arrange like this, right? Whatever, right? We can arrange like zigzag. But in your syllabus, we only interested in linear arrangements, arrange in a linear manner, and circular arrangement, arrange in a circular manner. We are not interested in anything else, right? Because these two are the most widely used arrangements anyway. Right. So let's move on to linear arrangement. Linear arrangement. So that means you arrange something in a linear manner, like this. Maybe this is another possibility, y, x, z. Okay. So if you have four numbers, 3, 2, 1, 5, this is one arrangement. 5, 3, 2, 1 is another arrangement. 2, 3, 5, 1 is another arrangement, and so on. So we don't care whether it's letters or numbers. So for us, this is something. This is a different thing. This is another different thing. We don't care whether X, Y, Z, O, A, B, C, O, 3, 2, 1, no, apple, grape, banana, or whatever. Okay. Right. So mathematicians who analyze these things and came up with some formulas so that we can easily calculate it rather than we think about those things all the time and come up with a pattern. So if you know the pattern, we can use it, but you need to understand and prove yourself that yes, this is correct. Right. Right. So to do this in a much more easier manner, I have uh, taken those as different cases. Right. Linear arrangement case number 1. Linear arrangement case number 2. Linear arrangement case number 3. Okay. And then with circular arrangement case number 1 and so on. So because when you are given a question, first of all, you need to understand, okay, there are different models, different scenarios. So different scenarios, we have different formulas. So your task is quickly identify what kind of a question is this. Is it permutation? It is combination. If it is permutation, is it type 1 question, type 2 question, type 3 question? Right. If it is type 1 question, so this is how you approach and this is the formula. Okay. So that is because otherwise it's going to be very stressful. Right. So let's look at the scenario 1 or case 1 or first type of questions you may get. That is, you have n number of elements. Right. N number of distinct elements. So we use the word distinct. Distinct means they are different. No two elements are the same. Something like this. These are distinct elements. Say red, blue, green. Those are distinct elements. Nimal, Amal, Kamal, distinct elements. If you have red, blue, and again red, of course, that is not distinct. Right. So let's assume we have n number of distinct elements. Right. N number of distinct elements. And how many ways we can arrange those n number of distinct elements linearly? Right. How many ways we can arrange those n number of distinct elements linearly? So you can write it as this is a notation npn. That means out of n number of distinct elements, you take all n number of elements and arrange. P means permutation. From n number of distinct elements, how many permutations are available if you take all n elements? And the answer is factorial n. The answer is factorial n. So this is something mathematicians observe. So they saw the pattern. So let's see whether this is correct. Say I have one element, just one element. How many ways I can arrange this? Just one way, because you just keep that linear. So that means we have n equal 1. So then how many ways we can arrange? Factorial 1. Yes, factorial 1 is 1. So it works. Assume that we have two elements, like x and y. How many ways we can arrange? X, y, y, x. There's no other way. Because linear means as a line. As a line කියලා දැන් මෙහෙමයි arrange කරන්න හරි line and line. So if you use this formula, it is 2p2. 2p2 is factorial 2. Factorial 2 is 2 into 1. That is 2. Yes. 2. And it works. Okay. And let's see whether it works for 3 elements. Right. So if it works, of course, you remember and use it. Right. So let's say we have 3 elements. Say x, y, and z. So this is one arrangement. Another one, x, z, then y. Another one, y, x, and z. Another one, y, z, and x. You can see these are different. Say you are taking photograph. These are all different arrangements of arranging 3 peoples. Fifth one, z, x, and y. Sixth one, z, y, and x. So how many ways? Do we have any other way? No. 6. And let's use this formula. 3 elements, 3 distinct elements, we take all 3 and arrange. 3p3, which is factorial 3. Factorial 3 is 3 into 2, which is 6. Yes, it is 6. Okay. So there's a question, what is the difference between doing Colombo BIT and Morotto BIT? So the difference is Colombo BIT is Colombo BIT, Morotto BIT is Morotto BIT. So I don't know what kind of question is that. I don't know what is your real question is. Okay. So it is from 2 different universities, 2 different syllabus, right? So that is a difference. Okay. Maybe you want to compare the 2 syllabuses. I don't know what is your question is, right? So if you want to compare the 2 syllabuses, definitely Morotto BIT is more technical, right? More maths oriented compared to Colombo BIT. Okay. So every university syllabus courses are different, right? Right. So that if your question is which is syllabus wise, Morotto BIT is more technical. Colombo BIT is also technical, but not as technical as Morotto. And while we learn this kind of maths in Colombo BIT, Morotto BIT, you learn more advanced maths. So if you find that this maths is difficult, definitely Morotto BIT maths is right, maybe 5 times difficult. If you think like that Colombo BIT is very technical and you need to do a lot of practical things, Morotto BIT you need to do right 5 times more practical things, technical things. So that is the difference. Okay. So there are less technical courses, moderately technical courses, highly technical courses. I would say BIT is a moderately technical course. Morotto BIT is very technical course, highly technical course. So whereas there are some IT degrees like IT with business, right? So more related to system, information systems and so on. So that kind of degrees are also there. IT degrees, right? Computer science degrees. Actually, computer science degrees are not less non-technical, and there are IT degrees which are less technical than Colombo BIT. So Colombo BIT is a moderately technical BIT degree course, okay, compared to Morotto. So there is a difference, okay. I don't know whether that is your question. Right. So therefore we have 6 ways. So therefore that is also correct. So if you check for 4 elements, X, Y, say A, B, C, D, you will find that you have factorial 4 possibilities. That is 4 into 3 into 2 into 1. That is 12 into 2, 24 ways. Right? So you can arrange and see for small number of things. If someone asks how many ways you can arrange, right? 50 elements. So then you can arrange and arrange and arrange, right? So the final answer is factorial 50. That is 50 into 49 into 48 into 1. Okay? Right. So that is scenario 1. Is it clear? So if you have n number of elements, distinct elements arranged in a linear manner, how many ways you can arrange? Factorial n times. How do you write this in our notation? NPN. It's a notation. Right. So let's look at the scenario 2. Right. Let's look at the scenario 2. If you have n number of distinct elements, again distinct elements, but this time you don't take all n. Right? You don't take all n elements, rather you take only r of those, where r is less than n. Say we have 5 distinct elements, like A, B, C, D, E, but we take only, say, 2 at a time and arrange linearly. How many ways you can arrange? How many ways you can arrange? So possible one arrangement is AB, another one is BA, because we take only 2, and maybe AC and CA, right? AD and DA, AE and EA, and BC and CB and BD, and so on, so on, so on. Of course, you can write and check if you have lesser number of elements like that. But what about if you have hundreds of elements and say you have 100 elements and you take 5 at a time? How many ways you can arrange? So mathematicians again analyze this and look at the answers and show a pattern. So that is, if you have n number of distinct elements, and out of those n number of distinct elements, if you take only r number of items at a time, where r is less than n, obviously. So number of ways you can arrange linearly is factorial n divided by factorial n minus r. And this is called NPR. Right? NPR. Factorial n divided by factorial n minus r. So that means if you have 5 distinct letters and if you take 2 at a time and arrange, that is 5p2, which is factorial 5 divided by 5 minus 2 factorial 3. That is 5 into 4, because 3 and other things get cancelled. How many ways? 20 ways. So I can write 20 ways. I wrote about 10. So there are few more. Okay. So just double check whether that formula is correct, right? For example, if you have 3 elements, and if you take only 2 at a time, how many ways you can arrange it? Let's do it according to the formula. That is 3p2. That is factorial 3 divided by 3 minus 2, 1. That is 3 into 2 into 1, 6. And let's see whether it's only 6. XY, XZ, YX, ZX. That is XY, YX, XZ, ZX. Then YZ, ZY. Do we have anything else? No. All are covered. බලන්න තව එකක් හරි විදියක් තියෙනවද කියලා? එකක්වත් විදියක් නැහැ. Okay? එකක්වත් විදියක් නැහැ. So yes, there are only 6 ways. So therefore, what is NPR? Factorial n divided by factorial n minus r. Again, n must be distinct elements. N distinct elements. And out of those n distinct elements, we take r and arrange linearly. Okay? Is it clear? So anyway, you need to remember this. Can't help. NPR is factorial n divided by factorial n minus r. Right, so this is exactly the question we did. So we have 3 distinct elements A, B, C. We take 2 and arrange 6 ways. Okay. Say we have 5 distinct elements. Okay, A, B, C, D, E. We take 3 at a time. So that is n equal 5. We take 3 at a time and arrange. That is R equal 3. How many ways we can arrange linearly? 5P3 NCR. That is factorial 5 divided by factorial 5 minus 3, which is factorial 2. That is 5 into 4 into 3, because 2 and 1 is getting cancelled. That is 5 into 4 is 20. 20 into 3 is 60. 60 ways. If you keep writing, you will find that there are 60 ways. Right. So that is case number 2. So let's move on to case number 3 if you don't have any question. Right. Now we are talking about non-distinct elements. So far we have been discussing about distinct elements. No two elements were the same. But what happens in our original collection, we have duplicate elements, something like A, B, C, and again A. Okay. And how many ways we can arrange them if we take all these elements? Now n is 4, but not distinct. Not distinct. So let's say we all take all 4 and arrange. How many ways we can arrange? So that we can see difference. Of course, these are not different. These are identical. So therefore, whether this A is there or this A is there, it's the same. It's the same because A is A. There's nothing called this is first day, this is second day. No, they are identical. So therefore, definitely this is not going to be factorial 4. Factorial 4. For example, let's say I have 3 elements, A, B, and A. 2 elements are the same. If this is A, B, C, how many ways we can do? Factorial 3. That is 3 into 2, 6. But this time, it is not going to be 6. Why? Let's arrange them. A, A. That is one way. Second one, A, B. Another one, B, A. Do we have any other way? Do we have any other way to arrange these 3? And it must be distinct from these available things. Can anyone tell me another way other than these 3? No way, right? Earlier we got 6, but now you get only 3 because no point arranging these 2 because it's again you get BA. Right. So therefore, if you have n number of non-distinct elements, and if you take all n elements and arrange linearly, now your formula is slightly different. Earlier it was factorial n. Right? Now it is factorial n divided by number of same elements. For each same elements, you need to take the factorial. In this case, we have B only once, A twice. So therefore, n is still 3. So therefore, now it is factorial 3, that is this, divided by factorial 1, factorial 2. And of course, factorial 1 is 1. So therefore, this is 3 into 2 into 1 divided by 2 into 1, which is 3. Yes, we have only 3. Right? We have only 3. Okay. Is it clear? So yes, we use the same notation, but this is when n is not distinct. Right? N is not distinct. Okay. Right. So let's do this question. How many distinct words can be made by taking all letters from A, B, B? So let's assume every combination has a meaning. Right? Just a word, not meaningful words, words. So we have 4 letters. And of course, words are always be arranged linearly. So we have 4 letters, therefore n is 4. But A we have twice. B we have twice. So therefore, it is yes 4P4. But this time it is not distinct, so therefore it's factorial 4 divided by factorial 2 factorial 2. That is 4 into 3 into 2 into 1 divided by 2 into 1 into 2 into 1. 2, 2, 2, 2, 6 ways. And these are the 6 ways. Okay. Does that mean if we have 1,000 elements, we need to check each and every element to find duplicate elements? Yes, right? So that is common sense, right? So how do you find duplicate elements? ඔයාට 1000ක් දුන්නොත් එහෙම duplicate element හොයන්න කියලා ඔයා 1000ක් බලන්න එපානේ. 1000 බලන්න ඕන. 1000 බලන්නකෝ 500 දිහා බලලා duplicate element බලන්න බෑ. Right? Simple answer is yes. ඒක common sense, right? Right. So that's all about linear arrangement. It doesn't mean that these are the only type of problems that can happen in reality, but this is your syllabus. Because in your syllabus, they have restricted to few scenarios. Even in A-level math syllabus, they have restricted it to few scenarios. Actually, your syllabus is pretty much like A-level math syllabus. Okay. There can be some other scenarios, but we don't look at those scenarios because then you need to remember more and more formulas and so on, right? So this is to give you the idea. Yes, there's something like this. There's a theory behind that. There are formulas which you can use to identify how many ways we can arrange things linearly. Right? Linearly. So one scenario we skip. What is that scenario? Can you find that one also? So we look at n distinct elements taking all n elements. Then we look at n distinct elements taking r elements. All are linear n. So third scenario, we took n non-distinct elements and taking all n elements. Can someone tell me which scenario we skipped? Which scenario we skipped? Again, listen to me. We have n distinct elements. If you take all n elements, how many ways we can arrange linearly? Scenario 2, we have n distinct elements. If you take r of those, and how many ways we can linearly arrange? Third scenario, if we have n non-distinct elements, if you take all n elements and arrange linearly, how many ways we can arrange? So my question is, which scenario we skipped? Which possible scenario we skipped? Because when you learn something, you must know what you learned and what you didn't learn.
So all non-elements, none are elements out of all distinct elements.
Not very clear what you're telling. Can you slow down and explain it?
Taking all n elements
Okay.
and
taking r elements out of non-distinct elements.
Yes, that is the scenario we skipped. That is, we have n number of elements which may not be distinct, and we take only r of those, which is less than n. So we did not cover that scenario simply because for that scenario, you don't have this kind of a simple formula. This kind of a simple formula. So then, of course, you need to use your intuition and pattern matching and do it. Anyway, you don't get that kind of questions. So just remember, we did not cover that particular scenario. N non-distinct elements, and if you take R elements, which is less than N, we did not cover that scenario because there's no simple formula for that. Okay. So for non-distinct elements, we only covered taking all N elements scenario. Taking all N elements, that is factorial N divided by factorial N1, N2, N3, that is the occurrences of same elements. Okay. Right. So I will give you a past paper question. Okay. because we are done half of your topic. I'll do a little bit older paper because we are going to do at least 3 years of papers fully. Okay, that is why I'm taking an older one because we are not going to cover these papers fully. But it's pretty much all the papers have the same syllabus. No question from that paper.
So how many questions do we get for this paper?
How many questions you get for which one? How many papers you get for?
Maths paper?
So that means you haven't opened a maths paper yet.
No, I opened in 2023 paper. There are 20 questions.
Okay.
Sorry, 40 questions.
Okay.
And
If it is 2 hours, usually it is 40 questions. It's roughly 40 questions. Okay. So you have two options, right? Either 2 hour paper, 1 hour paper. In semester 2, you all your other than the communication, because it's a EN subject, you have 1 hour paper. All the others, you have 2 hour MCQ. So 2 hour MCQ means roughly about 40. Okay, roughly about 40. Right. So this one, you can say roughly about 40, right? It can be 40, 41, 42, right? Not usually more than 45. Right. So, right. Do this question 35. How many ways can the letters of the word address be arranged? Right. Quickly do. So that means it must be a different word, distinct words. But we don't care about meanings. We care about whether it's a distinct word or not. And you need to simplify and give me the final answer also. Okay, so this is model 3 question, right? Model 3, that is n number of non-distinct elements, and you take all n elements because it says you take the word. Okay, you take the letters. Therefore, this is model 3, case 3 question. So n is, how many letters are there? 1, 2, 3, 4, 5, 6, 7. And A, you have only once. D, you have twice. R, you have once. E, you have once. S, you have twice. So therefore, this is NPN, but non-distinct. So therefore, it is factorial n divided by factorial n1, factorial n2, right? Factorial n3, and so on. So factorial n is factorial 7, because we have 7 letters, divided by, of course, factorial 1 is 1. Therefore, I don't write those. And this, we have 2 twice, S twice, D twice. So that is factorial 2, factorial 2. So that means 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 1 into 2 into 1. So that is 4. Right. So then you have 5 into 2 is 10, 10 into 6 into 3 is 18, 18 into 10 is 180 multiplied by 7. 8 into 7 is 48, 56, 5, 7 plus 5 to 12, 1260. So anyone got 1260? Yes, answer is A. Okay, answer is A. Okay, right. So those are the type of questions, okay? Right, so this is combination question because this says this they arrange, but this says select. So select is combination, not permutation. So therefore you can't do that. Okay, right. So let's move on to our second part also. So that is circular arrangement. Still arrangement, right? Still arrangement. Actually, this is not second part. Still we are in the first part. So far, what we discussed was arranging linearly as a line. So what about if you arrange as a circle? For example, if you have A, B, C, I can arrange it like this. Okay. So there's another arrangement. A, C, B. Now you can see this is A, B, C. This is A, C, B. It's a different thing. Do you have any other arrangement? Do you have any other arrangement? So sometimes you might feel like maybe there are other arrangement. And just arrange and see. Maybe you will feel like, okay, what about CBA? CBA, is it a different arrangement? Right? Though you call it CBA, okay? So now also this is also CBA. You can see CBA, CBA. So therefore this is not a different arrangement. Sometimes you may feel like it's a different arrangement, but you will see that when you rotate this, it is disarranged. Okay. Right. So again, mathematicians found that if you have n distinct elements, and if you take all n elements and arrange in circular manner, it is factorial n minus 1. If it is linear, factorial n. If it is circular, factorial n minus 1. Okay. That you can use at any time. For example, you have A, B, C. You want to arrange it in circular way. So that is 3p3, but this is circular. So therefore it is factorial 3 minus 1, which is factorial 2. That is 2. Yes, we have only two ways. All the other ways are actually one of these ways when you rotate. Okay. Say you have 5 elements, 5 distinct elements. How many ways we can arrange circular? That is 5p5, but circular. So therefore it is factorial 5 minus 1, which is factorial 4, which is 4 into 3 into 2 into 1. That is 4 into 3 is 12, 12 into 2, 24 ways. Linearly 24 into 5, but circularly only 24. Right. And here we look at only this scenario. That is n distinct elements and taking all n elements and arrange circularly. We don't look at n non-distinct elements and taking all n. No, we don't look at that. And then we have n distinct elements and we take r elements. No, we don't look at that also. Just one scenario. That is, you have n distinct elements and take all n elements and arrange circularly. Again, why we are only looking at this? Because only for this one we have a simple formula. For others, there's no simple formula. So that is the reason. It doesn't mean that you can't arrange other ways. So someone will say, okay, I have 3 distinct elements, I will take 2 and I have 10 and I take 3 and arrange circularly. Of course, you can arrange, but unfortunately, we don't have a simple formula. So therefore, for circular, we have only one scenario, n distinct elements and taking all n elements and arrange circular. That is factorial n minus 1. Okay. Right. So now we are done with permutations. And now we are moving to the second part, combinations. Okay. So combinations are somewhat easier also because we just select. We are not going to arrange. Okay. So therefore, this is the easier part. And just like we use P for permutation, we use capital C for combinations. Okay, combinations means selections, right? Selections. How many ways we can select? but we don't arrange linearly or circularly. Okay, right. So again, we can categorize them into cases or scenarios so that, and also look at what kind of cases we look at, what kind of cases we don't look at. And when you get a question, you can just put it into, okay, this is a model 1 question, model 2 question. So then this is how you approach it. Okay, right. So the case 1, say you have n number of distinct elements. Again, we are interested whether distinct or not. N number of distinct elements, and you take all n elements. And how many ways you can pick? How many ways you can select? Say I have 5 different peoples. We call them A, B, C, D, E. Right? N elements. Right? N distinct elements, and we take all 5. We have 5 distinct elements, and we take all 5. How many ways we can pick? Just one, because we need to pick those 5. If you have 3 people, right? Say we have 11 players, and we need to pick a team of 11. How many ways we can pick? Only one, because we need to take all 11. So therefore, NCN is 1. Okay, NCN is 1. Remember, NPN was factorial n. That is permutation. But this is selection, combinations. So NCN is 1. When you have n number of elements, and if you need to take all n elements, we have only one way, that is you take all these guys, all these things. Right, so that is the first formula, case 1. We have n number of distinct elements, and you take all n elements, we have only one way. We write it NCN, so therefore NCN is 1. Okay, right, case 2. We have n number of distinct elements, and we take only R of those. R is less than n. And how many ways we can select? How many ways? So that means we have 4 people. We need to take, say, we need to select a committee out of this. But one committee consists of only 2 people. How many ways we can create committee? How many different committees are possible? There's nothing called committees arranging like this. No, committee is committee, just 2 committee members. So one possibility is maybe AB. Another one is AC. Another one is AD. Another one is BC. Another one is BD. Another one is CD. And that's it, right? Because there's nothing called BC and CB. So that means N is 4, R is 2, because we take 2 at a time. And mathematicians have found that we can write it as NCR, that is factorial n divided by factorial n minus r. Remember, this part is NPR. If you look at NPR, factorial divided by factorial n minus r. Now NCR, you again divide by factorial r. See the patterns. You again divide by factorial r. So that is your NCR. So that means you have n number of distinct elements, and you want to select r number of elements. Select, not arrange. That is factorial n divided by factorial n minus r divided by factorial r. Okay. So that is our scenario number 2. And let's apply for this one. N is 4 and distinct. And we take only 2, R is 2. So therefore, 4C2 is factorial 4 divided by 4 minus 2, factorial 2, and again factorial 2. That is 4 into 3 into 2 into 1 is cancelled with this one, and again divided by 2. 3 into 2 is 6. Yes, we have only 6 ways. Right? We have only 6 ways. Is it clear? Is it clear? So the difference is, in NPR, we arrange them. In NCR, we select them. So there is a difference. Okay. So selection is different from arranging, right? Now here we have only AB, but no BA because we don't arrange. දැන් අපි ගත්තොත් එහෙම team committee එකක් දාලා committee එකට දෙන්නෙක් ගත්තට පස්සේ දෙන්නව වමිනුයි දකුණේ වාඩු කරාම එක committee එකකුයි දකුණව මාරු කරාම එක committee එකකුයි කියන්නේ නැහැ committee එක committee එක. හැබැයි ෆොටෝ එකක් ගන්නවා වගේ දැනකට ගියා X වමන දාලා Y දකුණට දැම්මම එක ෆොටෝ එකක් ගන්න පුළුවන්. දෙන්න මාරු කරාම තව ෆොටෝ එකක් ගන්න පුළුවන්. So that is permutation. වචනයක් හදනකොට නේද? AB කියන්නේ එක වචනයක් BA කියන්නේ තව වචනයක්. ඉතින් ඒක permutation. මේ arrangement. Arrangement වල arrange කරන්නේ නැහැ select කරනවා විතරයි. I hope it's clear. මොකද ඔය දෙක පටලවා ගත්තොත් ඒක මුකුත් කරගන්න බෑ. permutation combination දෙක ඔළුවට ගියේ නැත්තම්. ඒ දෙකේ වෙනස. සමහරවිට ඒ දෙක පැටලෙනවා. හරි සමහරවිට පැටලෙන මොකද්ද මේ කියන්නේ කියලා. හරි. හොඳට කල්පනා කරන්න. හොඳට කල්පනා කරන්න. මොකද්ද මේ දෙකේ වෙනස? හරි. ඒකයි මම කිව්වේ combination is the easier one, right? මොකද combination එක select කරනවා විතරයි. arrange කර යන්නේ නැහැ. හැබැයි permutation එක select කරලා arrange කරනවා. Right. So this is when you have n number of distinct elements and you take only R elements. Earlier we discussed n number of distinct elements and we take all n elements. Then obviously answer was 1. But here answer is factorial n divided by factorial n minus R divided by factorial R. Okay. So why do you think that we need to arrange to pick? No. So why do you want to arrange to pick? ඔයාගේ මල්ලක බෝල තුනක් තියෙනවා නම් නිල් රතු කොළ කියලා. ඒකෙන් බෝල දෙකක් ගන්න arrange කරන්න ඕනේ නැහැ නේ. මල්ලට අත දැම්ම ගත්තා. pick කරන්න arrange කරන්න ඕනේ. pick කරලා ඉවරලා තමයි ඔයාලට කැමති නම් arrange කරන්න. linear විදියට circular විදියට. එහෙම arrange කරන්න ඕන ෆොටෝ එකක් ගන්නවා වගේ අවස්ථාවක තමයි නේ. අනිත් අවස්ථාවල එහෙම arrange කර කර ඉන්නේ නැහැ. Right. So this concept of this NCR is there in lot of places, especially in algebra. So therefore, this you can take it as a general notation, NCR. Of course, you know the meaning of that. That is when you have n number of distinct elements, the number of ways you can take R number of elements. But because this selection is heavily naturally found in so many places, you just remember it as a normal formula also. Because in algebra, we use this. NCR is factorial n divided by factorial n minus R divided by factorial R. And also look at the special cases. What happens when R is 0? So when R is 0, let me erase this. මේවෙන් තමයි තනිකර AI වල එහෙම ගේම් ගහන්නේ. හරි AI වලදී අපිට ඕන විදි කීයක් මේක ටික් කරන්න පුළුවන්ද? විදි කීයක් arrange කරන්න පුළුවන්ද? ඔය කල්පනා කරලා තමයි හොඳ මේක හොයන්නේ ඊට පස්සේ. අපිට මිස් වෙච්ච සිනාරියෝ එකක් තියෙනවා. Right. So what happens if R is 0? That is NCB 0. That is factorial n divided by R is 0. Again factorial n divided by R is 0. Right. Then this get cancelled. Factorial 0 is, remember, 1 by definition. So therefore this again 1, this is again 1, so therefore it is 1. Okay. So then what about NCN? NCN. Then factorial n divided by n minus n is 0. That is factorial 0. And R is again factorial n. So again factorial 0 is 1. Then this get cancelled. Again 1. NC0 is 1. NCN is also 1. What about NC1? Of course, you can calculate this at any time. But if you can remember, that is also good. Factorial n divided by factorial n minus R. R is 1. And factorial R is 1. And factorial 1 is 1. Factorial n divided by factorial n minus 1 is what? N. Because this is n into factorial n minus 1. So NC1 is n. And there's another interesting connection, that is NCR equal NCN minus R. Okay, NCR equal NCN minus R. මොකද MCQ papers වල තමයි උත්තර දෙකක් තියෙනවා. ඒත් උත්තර දෙකම හරියි කියලා දන්නේ මේ ෆෝමියුලා එක දන්නේ නැහැ. For example, if I have n equal 5, R equal 3, that is 5C3 equal 5C2. This is 5 minus 3. So remember 5C3 equal 5C2. ඔයාලා උත්තරයක් වහලා දුන්නොත් එමේ 5C3 කියලා. තව කෙනෙක් උත්තරයක් දුන්නොත් 5C2 කියලා. ඔය දෙකම උත්තර දෙක සමානයි. Because NCR is NCN minus R. So how do you prove that NCR is NCN minus R? So let's use the definition. NC, let's do N minus R. So that is factorial N divided by factorial N minus R. Now R is N minus R. Okay. Then divided by factorial R. R is N minus R. So this is N minus N get cancelled. Factorial N divided by minus into minus is positive. Factorial R and factorial N minus R. And if you rearrange this, you get the definition of NCR, right? Because this is factorial N divided by factorial N minus R divided by factorial R. And this is the definition of NCR. So therefore, NCN minus R is equal to NCR. Right? NCN minus R is equal to NCR. So just keep this in mind. This is very useful. Otherwise, you don't get the full marks for the question. Sometimes, right? Not all the time. මේවා නම් එවරට හරි ටක් ගාලා ගලුවට එනවා සුළු කරාම සමීකරණ දැම්මම හරි NC0 is 1, NCN is 1, NC1 is n.
So can you explain the last one again?
This NCR is NCN minus R.
Yes.
So you just write NCN minus R and you apply the definition, because this n is n. Now my R is n minus R. N is n. Now my new R is, because this term is my R. Now new R is n minus R. So then by definition it is factorial n divided by factorial n minus R. That is this minus this, because this is my new R, right? Divided by factorial of below part, that is n minus R. And when you simplify this, n and get cancelled. That is factorial n divided by, here only we get factorial R and factorial n minus R. When you swap this, you get the original definition again. This original definition is NCR. So therefore, this is same as this.
Okay, sir.
Okay, this is same as this. Right. So therefore, at any time, if you see 8C, say 8C3, it is same as 8C5, because this is 8 minus 3 is 5. If you see any time 12C4, it is same as 12C8, because 12 minus 4 is 8. And if you simplify this using the formula, you will get the same answers. And see whether this makes sense also. This is if you have n number of distinct elements and you select nothing. How many ways you can select? Just you select nothing. So this is if you have n number of distinct elements, and if you want to select n number of elements, you have only one way, because you need to select all these guys. And if you select only one, okay, that means if you have 10, if you have select only one, you can select the first one, select the second one, third one, fourth one, and of course you have a number of ways. So you can just use the common sense also, right? Common sense also. Now you can see that NC0 is 1. Okay, NC0 is 1 because if you take 0 number of elements, right? So of course you don't select anyone. That's only one. Select කරන්න නැතුව ඉන්නවා කියලා පස් විදියකට select නොකර ඉන්න බෑ. Select කරන්න නැහැ. Select කරන්න නැහැ. You don't select anyone. Okay. Okay. Right. So all these formulas are valid And we heavily use that factorial 0 is 1. මේ ඔක්කොම prove කරලා ගත්තේ කොහොමද? Factorial 0 is 1 කියන එක පාවිච්චි කරගෙන. Factorial 0 1 උනේ නැත්නම් මේ කතාවක්වත් හරියන්නේ නැහැ. So therefore we need to take that factorial 0 is 1. Though it has no specific physical meaning, but to make sure that all the other concepts are whole together, we need to take that factorial 0 is 1. Like, for example, NCN is, we know that it is 1, right? If you have n number of distinct elements, how many ways we can select n number of elements? 1. But if you take it to the definition, that is factorial n divided by factorial n minus n divided by factorial n. So n minus n is factorial 0. And if factorial 0 is 1 only, because this is anyway 1, it is 1. And of course, in reality, it is 1. So therefore, you need to take that factorial 0 is 1. Okay? Okay, so shall we ask ChatGPT why factorial 0 is 1? මොකද දැන් ඔයගොල්ලන්ට හිතේ තියාගෙන ඉන්න ඕනේ නැහැනේ. සමහරට එයාට පුළුවන් වෙයි මොකද එයා අපිට වැඩිය දැන් බුද්ධිමත් වෙනවනේ වේගෙන්. ඒත් අපිට වැඩිය බුද්ධිමත් මිනිස්සු ඉන්න ලෝකෙක ජීවත් වෙන්න වෙනවා කරන්න දෙයක් නැහැ. මිනිස්සු මැෂින් තියෙන. බලමු එයාට ඊට වැඩි ඉන්ටරෙස්ටිං ආන්සර් එකක් තියෙනවද කියලා. Why do we take factorial 0 as 1? Right, you can see mathematical consistency. Consistency කියන්නේ මේක පවත්වාගෙන යන්න ඕන. නැත්නම් මේ කඩාව වැටෙනවා. Right, it ensures that the formulas involved in factorials work smoothly even when n equals 0. Right, හරි. ඒක මගේ උත්තරේම තමයි දුන්නේ. මේක තිබ්බම තමයි අර මුක්කු වගේ මේ කතන්දරේ එකට බැඳිලා තියෙන්නේ. මේක බිඳුවයි කියලා නොගත්තොත් එතනින් එහාට කතන්දරේ බිල් කරන්න බෑ. බිල් කරන්න බෑ. දැන් මම කියූප එක තමයි මේ කියන්නේ හරි. If you have 0 items, there is exactly one way to arrange them. Do nothing. Okay? Do nothing. So therefore it says, so while factorial 0 equal 1 might be arbitrary. Arbitrary කියන්නේ අහම්බයක් වගේ. At first glance, it's necessary convention that keeps the entire mathematical structure consistent and well behaved. Okay? Visual explanation නෙවුත් ඕන දානවා. ඒකට ඉතින් පින්තූරයක් ඇඳලා පෙන්නයි සමහරවිට හරි. Right. So now we have the NCR formula. Factorial n divided by factorial n minus r divided by factorial r. That means when we have n number of distinct elements, how many ways we can select r number of elements? Select, not arrange. Okay. And if you have n number of distinct elements, how many ways we can arrange r number of elements in linear way? We have formula. That is NPR. In NPR formula, this r factorial was missing. Right. So now we have two cases, right?
So that means arrange and select these two different things.
Yes. Because arrange means arrange. Select means select. Two different things, right? Because in selection, you don't arrange. You just select. Okay. You just select. Because no need to arrange. I told you when do we arrange things? Say you want to take a photo or something, you want to decorate something. So that is where you arrange things. You decorate, you take a photo so that it's a different sort of arrangement. But there are situations you just select, like a committee. Select. Select. You just select two people and partner them. So arrange කරන්න මමයි දකුණයි. Say you have 10 students, you need to create teams of 3. Teams of 3. So that is not arrangement, that is selection. අනිත් එක තමයි මේ 10 දෙනෙක් ඉන්නකොට teams of 3 එකම මේ සමහර විට ආයි තුන් දෙනා ගත්තම ටීම් 3යි හදන්න පුළුවන්. දැන් 9යි ඉතුරු එක නෑ ඉතුරු නෑ. එහෙම කතාවක් නෙමෙයි මේ කියන්නේ. So that is another thing, right? Lot of confusions are there. So when we say arrange, some students think like this. They say, assume that we have 10 students. Right? 10 students. A, B, C, D, E, F, G, H, I, J. Now we take 3 students. How many ways we can select? සමහර විටනවා දැන් මෙහෙම වුණාම හරි දැන් මේ තුන් දෙනාව ගත්තා. මේ තුන් දෙනාව ගත්තා. මේ තුන් දෙනාව ගත්තා. ඉතින් ඉච්චරයි දැන් පුළුවන්. ඒතර මෙයා ඉතුරු වෙනවා නෑ. එහෙම කතාවක් නෙමෙයි මේ කියන්නේ. What we are talking is how many ways we can select a team of 3. So one way is ABC. We don't care what happened to the others. Another way is ABD, ABE, ABF, ABG. So we are in that mindset, right? We are not breaking them into teams and put it into a tournament. No, we just want to pick a team. And how many ways we can pick? Okay. Not we break them into small teams. No, that is not what we are talking. So there can be a lot of confusions initially. If you don't understand exactly what is mean by selection. Selection means you just select. How many possible ways you can select? Right. So now we have 2 cases. If you have n number of elements, distinct elements, and pick all n elements, we have only one way to pick. That is NCN is 1. If you have n number of distinct elements, and if you take R elements, there are NCR number of selection. That is factorial n divided by factorial n minus R divided by factorial R. And also we look at some connections, especially the NCR is NCN minus R. So do nothing also pattern. So if you want to select and do nothing as an arrangement, yes. But what I'm telling is, I'm not interested in arranging. දැන් ඔයගොල්ලෝ හිතනවා මේ ගත්තම හැමතිස්සෙම arrange කරන්න ඕනේ කියලා. ඒකයි මේ තියෙන ප්‍රශ්නේ. නේද? ඔයගොල්ලෝ හිතනවා හැමතිස්සෙම ගත්තම arrange කරන්න ඕනේ. ඉතින් අරගෙන නිකන් ඉන්නකො. arrange කරන්න යන්නේ නැතුව. ඒකයි ඔයගොල්ලන්ට මේ ගොඩක් ඔය ප්‍රශ්න ඇති වෙන්නේ. හරි. ඔයගොල්ලෝ හිතනවා ගන්න හැම වෙලාවෙම arrange කරන්න ඕනේ කියලා. නෑ. අරගෙන නිකන් ඉන්න. දැන් කමිටියක් තෝරගත්තට පස්සේ කමිටිය දෙන්නට කියනවා ඔයා වමෙන් ඉන්නවා දකුණෙන් ඉන්න. දැන් ඔයා දකුණෙන් ඉඳලා ආවා වමෙන් ඉන්න කියලා නෑ. ඒගොල්ලෝ කැමති විදියට කියලා වාඩි වෙනවා. දැන් අපි කියමු ජජ් බෝඩ් එකක් කියලා. සිරස අපි කියමු සුපර්ස්ටාර්. එතකොට ඒගොල්ලෝ කැමති විදියට වාඩි වෙනකොට ඒ තුන් දෙනා වෙන විදියකට arrange කරනවා වෙන ජජ් බෝඩ් එකක් කියන්නේ නැහැ නේද? හරි. ඒ තුන් දෙනා බොහොම වාඩිනත් ඒක ජජ් බෝඩ් එක. සමහරවිට ඔයගොල්ලන්ට හිතෙන්න පුළුවන් මේ arrange නොකරොත් එහෙම නිකන් අර ඇඳුමක් ඇඳගෙන ආවගේ හෙළුවෙන් වගේ එකක් කියලා. එහෙම එකක් නැහැ. සමහර තැන්වල arrange කරනවා කියන එක අපිට අදාළ නැත. හැබැයි ඩෙකරේෂන් එකක් කරනවා ෆොටෝ එකක් ගන්නවා කියන තැන්වල තමයි arrange කරන්නේ. Okay, right. So now we move on to our third scenario, or third case, under combinations or selections. Okay, so we have again n distinct elements, and we take R1 of A type, or what a particular type, and R2 of a different type. Right. So listen to me very carefully. We have n number of distinct elements. Distinct elements like A, B, C, D, E. And earlier we took all n elements. Or we took R elements. Case 1 is you take all n elements. Case 2 was we take R elements. Now this is case 3. In case 3 we take R1 of type, say type X, because I have A as element. I said R1 of type X and R2 of type Y and so on. Maybe R3 of type Z and so on. So if so, how many selections or how many combinations are available? Right? How many combinations are available? Now, if you are a critical thinker, you may have a question. Listen to me again, okay? You may have a question, right? So listen to me again. These are distinct elements, right? Distinct elements. That is, A is different from B, B is different from C, C is different from D, D is different from E. Distinct. Distinct. Now, in this case, what we do is we take R1 number of a particular type and R2 number of a different type and R3 number of another type and so on. And then the number of selection is NCR1 because we have R1 type of X type we need into N minus R1C R2. That is the number of selections possible according to this scenario. Now, do you have any question, any doubt about my explanation? It is not the doubt about this formula, my explanation, my scenario. Is it my scenario clear? Right. So this is exactly the question I was looking for. Right. Right. So because you can see that it's sort of I'm telling a contradicting thing, right? So here I am saying distinct. මෙහෙන් කියනවා distinct කියලා මෙහෙන් කියන එක වර්ගයයි කියලා. ඒතර ආට අනිවාර්යෙන් එන්න ඕන අනිවාර්යෙන් මේවා ටිකක් මීටරෙන් නම් ඉන්නවාට ඔළුවට එන්න ඕන. යවෝ distinct නම් කොහොමද එක જાතියයි ඉන්නේ කියලා. දැන් මම කිව්වා ඒක මම හොඳට අහගන්න කියලා. I use this word distinct few times. So these are distinct elements, distinct, not the same. But now we are taking R1 of type A, R2 of type B, or R1 of type X, R2 of type Y, and so on. So then how do you know, how do we get that the same type of things when we have the distinct? So this type is different concept. Different concept. For example, maybe these are 5 people. These are 5 people. Say Nimal, Amal, Amali, Sumana, and Rehana. Okay, so therefore, definitely those are 5 different people. Now, if you take, say, 3 out of these 5 people, you know that the answer is 5C3, which is factorial 5 divided by factorial 5 minus 3 divided by factorial 3. That is, if you take 3 and if you take all 5, that is 5C5, which is 1. But now my question is something like that. Now we have, say, Amal, Nimal, Kamal, Nimali, and Rehana. Let's assume these are females. These guys are males. So these guys are males. But these are females. Nimali is a female. Rehana is a female. So then there can be a situation of scenario. I need to select a committee of 2. That committee must have 2 and 1 from male, that is X type, another one from female, Y type. Of course, these are 5 different people, 5 distinct humans, but there are commonalities, right? These 3 guys are males, these 2 are female. So maybe my requirement is whenever you pick a committee, you need to have at least 1 male. That means 1 male, 1 female, because it's 2. Now it is case 3 type of a question. Case 3 type of a question. So therefore, though it is unique, we may have common features among unique people. Okay. Is it clear? So now what is the answer? How many ways you can pick committee of 2? Each committee must have 1 male, 1 female. So you have originally we have 5 members. So therefore, n is total number of elements. We have 5. So therefore, 5C. Sorry. So this is not a example for this one. Okay. So let's take a different example. I will take this as a case 4. Actually, I took the wrong example. So this is example for case 4. That is take R1 of A and R2 of B. Okay, shall we do this and come back to case 3? Okay, we'll do like that. Okay, right. So this is my scenario because the example I took is related to case 4. Okay, right. So I have 5 people, A, B, C, D, and E. And A, B, C are males and they are different. And D and E are females. And D and E are females. Now my requirement is I need a committee of 2 and each committee must have, whenever you pick a committee, it must have 1 male, 1 female. 1 male, 1 female. How many number of possible committees are there? Now obviously you know that A and D is a possible committee. A and E is a possible committee. B and D is a possible committee. B and E is a possible committee. C and D is a possible committee. C and E is a possible committee, and that's all. So how many committees? 1, 2, 3, 4, 5, 6. I already know the answer 6. Because A and B is not going to be a committee because then both are males. D and E is not going to make a committee because then both are female. But C and D is going to make a committee. C and E is going to make a committee. Right? So now we have n equal 5. Right? N equal 5. But here we have n1 number of males, n2 number of females. And when you pick, we need to take R1 of n1 type, R2 of n2 type. Right? R1 of n1 type, R2 of n2 type out of this. So then the formula is this, because I take case 4 first, okay? That is N1CR1 into N2CR2. So there is a number of ways you can pick the committees. So in this case, committee, because we have a restriction. So if you take it to the numbers, N1 is 3, that is 3C1, because R1 is 1 male, and here 2C1 into 2C1. And 3C1 is, remember NC1 is N. නැත්තර සමීකරණ දාලා බලන්න. ඒක මම කියව මතක තියාගෙන ඉන්න වටනවා කියලා. NC1 is N. නැත්තර NCR සමීකරණ දාලා සුළු කරා. Right. So therefore 3C1 is 3, 2C1 is 2. Answer is 6 ways you can pick committees. And yes, we got 6. Because AD, AE, BD, BE, CD, CE. There's nothing called AB, there's nothing called AC, there's nothing called BC, there's nothing called DE. So this is the formula. So we have total n number of elements, but out of those, we have n1 number of type A, n2 number of type B, and n3 number of type C, and so on. And if you want to select such that you need R1 of type A, R2 of type B, R3 of type C, and so on. How many ways you can pick? You take N1CR1, N2CR2, N3CR3, and so on. So it's something like you take them as separate groups, though it's a set of people, because these are now one group. From this group, you need to pick R1, so therefore N1CR1. From this group, you need to pick R2 from N2. So therefore, you don't care about this total N now. You can see the total N is not in your formula. You now consider this as 2 subgroups. From N1, you take R1. From N2, you take R2. Therefore, N1CR1 into N2CR2. Okay. ගොඩක් අයට උතන ඉන්නවට ගැහැණු පිරිමි කතන්දර තමයි වට දෙන්නේ ගොඩක් අයට. මේකේ අඩුම ගානේ දැන් එහෙම තියනවා නේද? අඩුම ගානේ කමිටු වලට කාන්තාව දෙන්නෙක්වත් දාන්න ඕන. Okay. So then you can go for this kind of a thing. Okay. Right. So this is an example. There are 12 boys and 14 girls in a math class. So that means you have 12 boys and 14 girls. Of course, these guys are unique. So therefore, these are 26 different humans. But there's a commonality. 12 of them are boys, 14 of them are girls. Find the number of ways we can select a team of 3 students from the class to work on a group project. The team consists of 1 girl and 2 boys. So you need to pick a team of 3. The team must have always 1 girl and 2 boys. So that means from these boys, you need to pick 2. So this is my N1 and this is my R1. And from these girls, that is N2, you need to pick only 1 because 1 girl. So how many ways they can pick a team? That is 12C2, that is N1CR1 into 14C1. So 12C2 is, remember, factorial n divided by factorial n minus r divided by factorial r. That is factorial 12 divided by factorial 12 minus 2 factorial 10 divided by factorial 2 into, this is factorial n divided by factorial n minus r, that is factorial 13 divided by factorial r, factorial 1. Then make a right? Because this is factorial 12, this is factorial 10, therefore we have 12 and 11 because other things are getting cancelled. And here we have 2. And here we have only 14 because factorial 13 is getting cancelled out because factorial 14 is 14 into factorial 13. And of course, factorial 1 is 1. So this is 7. So that is 7 into 2 is 14, 1, 84, multiplied by 11 means 4, 12, 924 ways. So we can select a team in 924 ways, which consists of 2 boys and 1 girls. Right? 2 boys and 1 girls. Is it clear? Is it clear? Okay. Right. So that is actually I took case 4. Case 4. Take R1 of A and R2 of B. Actually, this is one of the very famous or popular type of question. Because this is very practical, right? Sometimes there are restrictions like that. Restriction like that. මේ ජාතියෙන් මෙච්චරක් අඩුම ගාන ඉන්නවා. So it become more interesting when they say at least you need this number of things. So that is very interesting there. සමහරලාට කියන නෑ එහෙම දෙන්නෙක් ඕනේ නෑ අඩුම ගානේ ගෑනු ළමයි එක්කෙනෙක් ඉන්නවා. නැත්නම් අඩුම ගානේ දෙන්නෙක් ඉන්නවා. එතකොට ආට ගෑනු ළමයි 3 දෙනෙක් ඉන්නේවත් ගන්න පුළුවන්. ඔක්කොම ගෑනු ළමයි දාලා ගන්න පුළුවන් ටීම් එක ගන්න. So those are very interesting scenarios. Right. Now anyway, that is our case 4, right? That is our last case actually. For combination, now let's move on to case 3. මොකද මම ගත්ත example එක වැරදි ඉස්සෙල්ලා හරි. Right. So now let's move on to case 3. මේ දෙක ගොඩක් එක වගේ නමුත් දෙකක්. ඒකයි මට උදාහරණේ පටලව ගත්තේ. Now let's move on to our case 3. So in our case 3, because the formula is also different, so we have n number of distinct elements. N number of distinct elements. N distinct. But this time our requirement is different. හොඳට අහන් ඉන්න. මේ මම ඉස්සෙල්ලා වැරද්දලා explain කරන්න ගියේ. ඒකයි උනේ. So we have n number of distinct elements. What we are going to do is we are going to take R1 of this and give it to someone. R1 is take and give it to someone. Say we are giving it to X. නැත්නම් ඒගොල්ලෝ යවනවා එක ටූර්නමන්ට් එකකට. R1 පිරිසක්. So then we take R2 number of elements for something else. We have in this thing anyway. Obviously, R1 plus R2 must be less than N. So our requirement is we take R1 out of N, and then from the rest of the guys, we take R2. How many ways we can select? How many ways we can select? Say we have 10 players. We need to send them same day. There's a tournament, 2 tournaments. Okay, 2 tournaments. For this tournament, we need to send 3-member team. 3-member team. For this tournament, we need to send 2-member team. We have altogether 10. So the question can be, how many possibilities are there? How many possible selections are there? Of course, if you have A, B, C, D, E, F, G, H, I, J, one possibility is you take A, B, C and send to this, and take D and send to the other one. Another possibility is take A, B, C here and I, G here. Another possibility B, C, D here and A, E here, likewise. Now you should get it. So the question is, how many possibilities are there? ඒ කියන්නේ ABC යනකොට D යනවා කියන එක possibility එකක්. ABC යනකොට අරයට IG යනවා කියන සමහර විතර වෙන එකට කවන්නේ නැහැ. So some of the guys will be remain, that is fine. So if you have this kind of a scenario, this is how you calculate it. How many ways or how many possibilities are there? First you take from all your n elements, because you can select this from your all n elements because all the guys are available to you initially. So therefore it is NCR1. Because all 10 people, you select 3. Into, now we have N minus R1 team members. Because R1 is already sent. From that N minus R1, you select R2 number of elements. And that is the possibility. That is the number of possibilities. Okay. From entire N, you pick R1. From N minus R1, because we have already said taken R1 elements, you pick the R2 and you multiply because these are possible combinations. Possible combination. So that is our case 3. Okay, case 3. So now we are done with permutation and combinations. Okay, මේ දෙක තමයි පැටලෙන්නේ ගොඩක් අය. case 3 සහ case 4 පැටලව ගන්න එපා. Okay, right. So this is a practical question for this scenario. Committee select කරපු එක case 5. පිරිමි මෙච්චරක් ඉන්නවනේ, ගෑනු මෙච්චරක් ඉන්නවා. Say I have 5 different toys. Different toys. හරි. මේ toys toys පහක්. එකක් plane එකක්, අනිත් එක boarding එකක්. හරි. So we have 5 toys. Suppose we want to find the number of ways in which 5 different toys can be divided among 2 children. අපි මේ toys ටික බෙදලා දෙනවා දෙන්නෙක් අතර. First child get 3. Right? So now n is 5. So the first child get 3. එයාට 3ක් හම්බ වෙනවා. ඕන 3ක් හම්බ වෙනවා. A B C වෙන්න පුළුවන්, A B D වෙන්න පුළුවන්, C D වෙන්න පුළුවන්. Second child get 2. එතකොට ඔක්කොම අන්තිමට ඉවරත් වෙනවා. So how many possible ways they can get the toys? ඒ කියන්නේ එක possibility එකක් තමයි මෙයාට ABC මෙයාට D. තව possibility එකක් තමයි මෙයාට ABD මෙයාට C. තව possibility එකක් තමයි මෙයාට CD මෙයාට AB. අන්න එහෙම කීයක් තියෙනවද විදි? හැබැයි arrange කරන්නේ නැහැ. හරි ABC කියන එක ආයි arrange කරන්න ABC වෙනකොට මෙතන CBA කියලා එහෙම කරන්නේ නැහැ. Just how many possibilities. So how do now this is NCR1 into N minus R1 CR2 problem. Because when you give toys to the first child, we have 5. So out of 5, we need to pick 3. Now, when you give 3, we have only 2. Then out of 2, you need to pick 2. And you multiply because these are combinations. And 5C3 is factorial 5 divided by factorial 5 minus 3 is 2 divided by factorial 3. And 2C2 is obviously 1, or you can say factorial 2 divided by factorial 2 minus 2, which is factorial 0 divided by factorial r. And of course, this is 1. This is obviously 1. 1 තමයි මොකද තුනක් දුන්නට පස්සේ ඉතුරු දෙක කොහොමද අනිත් එකන දෙන්න බෑ එතන අය අරෙන් කරගන්න. මොකද මේ තුනක් දුන්නම අනිත් එකනට ඉතුරු වෙන්නේ දෙකයි ඉතින්. ඒක කොහොමද දෙන්න ඕන? එයාට ආයෙ වෙනස් කර කර දෙන්න බෑ. Right. So therefore, this is anyway 1. So this is 5 into 4. Then this get cancelled. 3. And then this is 2. So this is 10 ways. There are 10 ways. විදි 10කට මේක යන්න පුළුවන්. ඒ කියන්නේ මෙයාට ABC ගිහිලා අරයට D යනවා. මෙයාට ABD ගිහිලා අරයට C යනවා. බලන්න 10යි වට එන්නේ. Right. Is it clear? Is it clear? Now we have done. And the challenge is when you see the question, first of all, you need to identify is it a combination question or permutation question? If it is a permutation question, which category I can put it? If it is a combination question, which category I can put it? Sometimes you can't clearly put it into one category. Sometimes it's a combination of those categories. That is where the things are really challenging. Of course, it is challenging. It's challenging. Some questions even I can't straight away give answer. Sometimes after I think about few scenarios, I get an answer. Sometimes my initial answer is not correct. Okay, that is part and parcel of challenges. I can still remember we learned this in A level, right? Because A level syllabus still this topic is there. But I decided, okay, I am not going to do this question in my A level. If you do this question, it's very less time consuming and we get a lot of time for others. But during my A level, I never fully understood what is this. මට නිකන් combination permutation දෙකක් පැටලිලා තිබුණේ. දැන් නම් එහෙම පැටලිලා නැහැ. Okay. ඒකට ඔකට යන්නේ වෙලාව පොඩ්ඩයි. කල්පනා කරලා උත්තරේ ලියුවා. හරි දැන් ඔයගොල්ලෝ දන්න A level paper එකේ හරි සුළු කරන්න එනවා අවකලන අනුකලන ගණන් එහෙම පිටු ගණන්. ඒත් අපි අර පිටු ගණන් සුළු කරන ගාන හදනවා කම්බිනේෂන් ගාන හදන්නේ. බහුතරේ මම විතරක් නෙමෙයි. යාළුවොත් එක්ක කතා බහ කරනවා. බහුතරේ මම දන්න විදිහට අපේ පන්ති වල හිටිය අයගෙන් 100ට 5ක් 10ක්වත් ඔක් කරන්නේ නැහැ. ඒ ලෙවල් විභාගෙට ගිහින්. ඇහුවම කියන්නේ අපෝ කම්බිනේෂන් ගාන සංකරණ සංයෝජන ගානට නම් අපි අත තියන්නේ නැහැ. ඇයි ඒ? Tamanටම ෂුවර් නැහැ උත්තරය හරිද කියලා. Tamanටම ෂුවර් නැහැ අනිත් ඒ ලෙවල් දෙන්නේ ටිකක් කරකෝල අතහැරපියව ඒවා දෙන්නේ. විශේෂයෙන් ඒ කාලේ මම දන්නේ දැන් වැඩිය ඒ කාලේ දෙන්නේ කරකෝල අතහැරලා. හරි? ඉතින් ඉස්සර අපිට ප්‍රශ්න 12න් 6යි කරන්න තියෙන්නේ. එතකොට අපිට 6ක්ම අතාරින්න පුළුවන් ඉස්සර. දැන් ඔයගලන්ට එහෙම නැහැ නේ. ඔයගලන්ට MCQ උන්දී. හැබැයි ඔයගලන්ට එහෙම ගොඩක් අමාරු ඒවා දෙන්නේ නැහැ. Okay? ගොඩක් අමාරු ඒවා දෙන්නේ නැහැ. Right. So let's do some past paper questions. Let's do some past paper questions, okay? Right, do the 36 question. මේක කරනකොට අය ඔළුව හොඳටම හරියනවා හරි. මලකට තියෙනවා ඔක්කොම ගැලවිලා නියුරෝන වැඩ කරපු නැති නියුරෝන ටික වැඩ කරන්න පටන් ගන්නවා. එකපාරට එන්ජිම ස්ටාර්ට් වෙනවා. In how many ways can class of 10 students be divided into two groups with 6 and 4 students? 6 and 4 students. First of all, you need to identify is it a combination question or permutation? If it is a combination question, what model of a question is this? Or is it something not a pure model? Maybe then this is more related to that model. or maybe this is a combination of two models, something like that. But these are very interesting questions, right? Of course, in A level, we did not attend those because it was a very competitive exam and we never wanted to take too many risks because we had targets to get the maximum in A levels. It's like a risk management. But when you do it in a very relaxed manner, it's a lot of fun. Of course, your BIT is not like A level, right? A level කරනවා competition නැහැ BIT වල. ඩිග්‍රියක් කරනකොට එහෙම A level තමයි අර competition නැති. මොකද ඒ කාලේ private university තිබුණේ නැහැ අපිට. එක නිකන් නමටවත් නැහැ. ලංකාවටම තිබුණේ එක private university එකක්වත් නැහැ අපි A level කරා. ඩිග්‍රියක් ගන්න. NSBM එක විතරක් තියෙනවා. ඒකෙනුත් දෙන්නේ ඩිප්ලෝමා එකක් විතරයි. ඩිප්ලෝමා එකෙන් එළියට ඩිග්‍රියක් දෙන කිසිම යුනිවර්සිටි එකක් ලංකාවේ නැහැ අපි A level කරා. ඒකට කොහොමද? ඒකට ඔයගොල්ලෝ හිතාගෙන බලන්න කොහොම කම්පිටිෂන් එකක් තියුණාද කියලා. අපි A level කරන කාලේ. ඒකද වෙන කරන්න දෙයක් නැහැ නේද අපිට. විශ්වවිද්‍යාල ආණ්ඩු කැම්පස් එකකටම යන්න ඕන. ලංකාවේ නැහැ. එහෙම නැත්නම් රට යන්න ඕන. හරි IT වත් මෙලෝ මගුලන්නේ නැහැ. මෙලෝ විශ්වවිද්‍යාලයක් නැහැ. ප්‍රයිවට් ඒවාවත් නැහැ. හැබැයි අපි මේවා කළා අවුරුදු 3ක් විතර එනකොට ඔන්න ප්‍රයිවට් යුනිවර්සිටිස් එන්න පටන් ගන්නවා. ඉතින් අපි කැම්පස් වල ඉන්නකොට ඔන්න ප්‍රයිවට් යුනිවර්සිටි පටන් ගන්නවා. හැබැයි අපි ඒලව කරනකොට නැහැ. ඒලව කරනකොට බකට් දානවා නේද? මරාගෙන කන්න හදනවා. දාන්න එපා කියලා. ඔය දැන් මෙඩිකල් කොලෙජ් දාන්න දෙන්නේ නැහැ වගේ ඉස්සර ප්‍රයිවට් යුනිවර්සිටි පටන් ගන්න දෙන්නෙම නැහැ. කාලා ගන්න. Right. In how many ways can a class of 10 students can be divided into two groups with 6 and 4? Right? 6 and 4. That means we are going to use all 10, right? So initially we have 10. N equal 10. Right. From 10, we are going to pick first 6. That is my R1. Right. We can pick any 6, but we are not going to arrange. So this is definitely combination. So this is not going to be a permutation question. Because you just pick a group. So now we have pick 6. How many ways we can pick 6 from 10? 10C6. Now we have pick 6. Now you need to pick another 4. R2 is 4. But remember now we have only 4. So therefore anyway ඉතුරු වෙන 4 දෙනාට මේකට දාන්න වෙනවා හරි. හැබැයි ඒක ලස්සන ලියමු. Now this is now 10 minus 6 because 6 is already taken. So we have only 4. 10 minus 6 C. Out of those 4 we need to pick 4. Of course. 4 දෙනෙක් pick කරන්න like විදියයි. So therefore that is why we say NCN is 1. So therefore this is you can multiply now. 10C6 is දැන් මෙයාට සුළු කරපු උත්තර තියෙනවා හැබැයි මේ උත්තරේ තියෙනවා අපි සුළු කරලත් බලමු. 10C6 is factorial 10 divided by factorial 10 minus 6, which is factorial 4 divided by factorial R into 10 minus 6 is 4. 4C4 is, anyway, now factorial 4, factorial n minus R, that is factorial 0 and factorial R. Anyway, it is 1. It is 1. And here we get 10 into 9 into 8 into 7 because 6 and other things get cancelled for this. Then 4 into 3 into 2 into 1. Okay. So 4, we can say 2 here. And this 2 and this 2 get cancelled. 3, maybe 3 here. 7 into 3 is 21. 21 into 10 is 210. Right? We don't have 210, right? No, we don't have 210. So that means this is not an answer, right? I hope I did not make a mistake. So therefore, this is not an answer. So then what about the other things? So this is anyway 1. This is anyway 1. So therefore, this is 10C6 into 1.
10C6.
So therefore, this is an answer. is an answer. So if 10C6 is an answer, remember NCR is NCN minus R. So if 10C6 is answer, 10C 10 minus 6. 10 minus 6 is 10C4 is answer. Because NCR is NCN minus R. Whenever 10C6 is answer, 10C4 is answer. That is 10 minus 6. So therefore this is an answer. And obviously these p values are not going to be answers, right? නරක වෙලාවට සුළු වෙලා උත්තරේ දන්නේ නැහැ. ඒව බල බල ඉන්න මට වෙලාවක් නැහැ. So I will go for A and C. Right? I will go for A and C. So 36 I will go for A and C. Let's double check the answer. 2017. 36. Yes, A and C. A and C. Okay. So answers are A and C. You can see it. If you know the subject, if you have that confidence, self-confidence, it takes time. Right? It takes time. Unfortunately, in 1 month's time, you have the exam. So you need to build as much confidence as possible because you can't skip questions. These are MCQs. Okay. Right. So this look like a interesting question. I mean, interesting and the මාවත් නිකන් ගෑහෙනවා හැබැයි. මටත් බයයි දැන් මේ question එක අත ගහන්නත් කමන්නේ අත ගාමු. බැරි වුණොත් කරන්න දෙයක් නැහැ. කරන්න බෑ. 35. මේ question එක දකින්නකොට හැමතිස්සම අපි උනත් එකපාරට පොඩ්ඩක් ගැස්සෙනවා. කරගන්න පුළුවන්ද කියලා. හරි? right කරගන්න බැරි නම් ඉතින් නොකරමු. පුළුවන් නම් කරමු. Right. Do the 35th question. Remember vowels are A, E, I, O, U, right? ඒවා ඔයගොල්ලෝ දැනගෙන ඉන්න බෑ. So here the vowels are U, A. There are two vowels. Others are not vowels. ඒ දෙන්න එකටලු ඉන්න ඕනේ. කියන්නේ U, A එකටලු ඉන්න ඕන කොහේ හිටියත්. ඒක මුලේ ඉන්න පුළුවන්, අග ඉන්න පුළුවන්, මැද ඉන්න පුළුවන්. ඔය දෙන්න එකට ඉන්න ඕන. අපි හිතුව මේ දෙන කපල් එකක් මේ දෙන ෆොටෝ ගහන්න ගියාම හැමතිස්සෙම මේ දෙන එකට නෑ. අපි දෙන එකට විතරයි නේ. අපි දෙන කොයි වෙලාවත් වෙන් වෙන්නේ නෑ. අනිත් අයට පුළුවන් ඕන විදිහට වෙනස් වෙන්න. මේ දෙන එකට නෑ නෑ. අපි දෙන්න මැදට කවටවත් එන්න බෑ. Okay. Right. Do it. And definitely this is a permutation, right? Because how many ways, how many words means, different words means when you rearrange, it's a different word. So therefore, by look of it, you must first identify that, okay, this is a permutation question. Can someone give me the answer and explain it? Explain your logic. This is my answer. This is how I got the answer. This is my logic. Yes, when we did our A levels, obviously our brain was also not 100% developed, right? So therefore, during A level, doing this question was extremely challenging. So that is why a lot of students, they skip this. They skip this. Of course, sometimes you can do it in 5 minutes, but in A level, we don't like to take too many risks. Too many risks. But when you are relaxed, this is a very interesting topic. And of course, even ChatGPT can give the answer. Because ChatGPT is intelligent, right? It should be able to give the answer without any issue. Anyone got the answer? And I need the explanation, not just the answer. This is my logic. So I don't need the answer, I need the explanation also. Now remember, if you don't have the special condition, that is all vowels in together. If you don't have that condition, of course, that is very easy question. So that means you have non-distinct elements and n is, now I do this without considering this, okay? Without considering this, then n is 1, 2, 3, 4, 5, 6. And we have S only once, U only once, N only once, D only once, A only once, Y only once. So therefore, this is basically because we need to take all the letters because it says how many words can be made from the letters. Letters means you take all the letters. Okay. So therefore, the answer is factorial 6. But that is if you don't have this condition because these are distinct elements. Same letter is not twice. So that means we can create factorial 6. That is 6 into 5 into 4 into 3 into 2. But now the question is not that. Right? Now we have 6 letters. Yes, we have 6 letters. But vowels must be together. But what are the vowels here? U is a vowel and A is a vowel. And others are not vowels. So if vowels always want to stay together, we can consider those two as one. මුන් දෙන්න අර ජෝඩුවක් වගේ ජෝඩුව එකට බැඳලා ගන්නවා. දැන් මුන් දෙන්න හැමතිස්සෙම එකටනේ ඉන්නේ. අපි කියනවා හරි මුන් දෙන්න එකයි. ඔය දෙන්න අපි එකයි කියලා ගන්න. මොකද ඔය දෙන්න හැමතිස්සෙම ඇලිලානේ ඉන්නේ. So therefore now we have S N D Y okay and UA. UA එකට ඉන්නවා. UA එකට ඉන්නවා. අපි මෙයාව ගන්නද එක ලෙටර් එකක් කියලා. මොකද මේ දෙන්න වෙන් වෙන්නේ නැහැ. So then how many ways we can arrange? Now we have 1, 2, 3, 4, 5 because these two are glued together, right? So out of 5, we need to take all 5 because it's a word. So therefore it is factorial 5. Is that factorial 5 the answer? දැන් පොඩි වැඩක් තියෙනවා. මේ දෙන්න එකට හිටියට මේ දෙන්න එහාට මෙහාට වෙන්න පුළුවන්. මොකද දෙන්න එකනේ. UA කියන දෙන්නද අපි හිතමු මෙහෙම තියෙන SNDY UA. දැන් මේක එක විදියක්. මේ factorial 5 ඇතුලේ. හැබැයි මේ දෙන මාරු කරලා තව එකක් ගන්න පුළුවන්. මොකද මේ දෙන එකට හිටියන් දෙන්නට මාරු වෙන්න පුළුවන්. SNDY AU. So therefore for each of these combinations we need to multiply by 2 because these two guys can interchange. මෙයා මෙහෙට යන්නේ නැහැ. හැබැයි මේ දෙන්න අතර මාරු වෙන්න පුළුවන්. ඒකට වෙන වචනයක්. So therefore, my answer is, I don't know whether it's correct or wrong. According to my logic, my common sense, my logical thinking, maybe I'm wrong. Sometimes we make mistakes. But my answer is factorial 5 into 2. Factorial 5 because I bound these two together. So that I took it as 1. Then these are distinct elements because other letters are also distinct. So then it is factorial 5. But because these guys can interchange for each arrangement, I just multiply it by 2. So then it is 5 into 4 into 3 into 2 into 1 into 2.
Why do we multiply by 2?
Sorry?
Why do we multiply by
Because
2?
these two guys can change. U and A. U and A.
If
Because
there are three vowels, then we have to multiply by 3.
not 3.
No,
Factorial.
if there are 3 vowels
3 vowels because say these are the 3 vowels.
together, if we take
A, U, E. Because this is the others are here. Now this can be A, U, E, A, E, U. Right? What else? A, E, A, U, E, U, A. Then U, E, A, U, A, E. So therefore not by 3. Factorial 3. 3 into 2.
yeah, sir.
Yeah. Okay. So you need to think really hard because these 3 guys can be arranged in factorial 3 ways now. Right. So let's see whether this answer is there. I don't know whether my answer is correct. This is my answer. Right. Right. let's see, 5 into 4 is 20. 20 into 3 is 60. 60 into 2 is 120. 120 into 2 is 240. So my answer is 240. Because 240 is answer, I will not take 120. And of course, factorials 5, 5, 4, 3, 2, 1. No, it can't be factorial 5 because factorial 5 into 2. It can't be factorial 6. But මේවා සුළු කරලා තමයි බලන්න පුළුවන්. Is it factorial 6? I don't think it is factorial 6. This is factorial 6 means 6, 4, 3, 6, 5, 4, 3, 6, 5, 4, 3. Other things get cancelled. That is 30. 6 into 5 is 30. 30 into 12. බලන්න ඒකේ නෝට කියලා 0 නෑනේ. I'll go for B. 35, I'll go for B. Okay. Let's see whether 35 answer is correct. 35, is it B? Yes, answer is B. 35 answer is B. So these are very interesting questions, but only thing is you need a bit of experience, maturity. මේ ඔකට අර අපි කියන එකට පත්තියන් වෙන සාමාන්‍යයෙන් අවුරුද්දක් විතර යනවා සමහරවල්ලාට හරි. අපිට ඕගලන්ට එක්සෑම් තියෙන මාසෙකින් ඒක වෙන මොකද තාම A level කරද්දී අපිට අවුරුද්දක් විතර තිබුණා හැබැයි. අවුරුද්දක් විතර. මොකද මැද හරියනේ කරන්නේ. ඒත් ඕක එකට වදින්නේ නැහැ සමහරවල්ලාට. But if you do a lot of questions, right? Of course, not every question is hard. Some questions are easy, right? And the more you have the experience, then all of a sudden you will see, okay, දැන් මම මේක කරේ මම මේක ගණන් මගේ ඔළුවේ කොහේ හරි හැංගිලා හරි තියෙනවා. හරි? ඒක තමයි ඔළුවට ආවේ. දැන් ඔයගොල්ලන්ගේ ඔළුවේ හැංගිලා තියෙන විදියක් නැහැ නේද? first time කරන අයගේ. ඒකට ඒ experience එක ගන්න ඕන. ගණන් හදලා.
I didn't understand how to see whether it is a permutation or combination. How
So
to select it.
you need to create words. How do you create words from letters? By mixing.
Yeah.
So mixing is permutation.
Okay.
Okay. So we create words by mixing letters. So if I have two letters A, B, we can create two words A, B and B, A. If I have A, B and C, A, B, C, A, C, B, B, A, C. So when we say words, it's mixing. When we say committee, team, there's no mixing. There's no mixing. Or if someone says how many ways you can take a picture, it's a permutation. So this is, earlier we did something like that. Right. So there's a clue. Use your common sense also. I told you,
They
right?
ask how many ways means it's permutation.
Yes, how many? No, no, no. If someone says how many ways you can select committees, it is combination. So don't go by how many ways. Right? Because how many ways you can select committees is combination. How many ways you can arrange them or how many ways you can create a word is permutation. So therefore, don't go by the word ways. Right? That is why I told you, if it is something like arranging things, decorating things, taking photos, words, those are permutations. Or if you are just selecting a committee, team, those are combinations. So therefore, you must go by the noun, not by the verb. Okay. Right. So let's see whether we can do another question. Let's take another page. Right, so this should be easier question. It looks easy. Just do it. I don't know. But it looks like easy. Give the number of ways of making a necklace using 10 beds with different colors. So you can assume that those 10 beds are of 10 different colors because it says different colors. දැන් බෙඩ්ස් කියන්නේ මොනවද කියලා මම දන්නේ නැහැ. ඇත්තම කතන්දරේ මම දන්නේ නැහැ මොනවද කියලා. හරි. මොනවා හරි ඉතින් මේ මාලා හදනවා නම් පබළු හරි මොනවා හරි වෙන්නේ. මම මාලාපනය කරන්නේ නෙමෙයි මම දන්නේ නැහැ මේ මොනවාද කියලා. හරි. ඔය මොනවා හරි දෙයක් කියලා හිතාගෙන ගන්න හදන්න. beat bet so beat so I don't know. මම ඔයා ගැන ඉච්චර උනන්දුවක් නැහැ මාල බලලු ගැන. Number of ways of making necklace using 10 these with different colors. These 10 are of the 10 different colors. It says different colors. What is your answer? Now, what kind of a question is which model? And because they are in different colors, that means 10 different colors, definitely these are n distinct elements. Right? N equal 10 distinct. Right? Number of ways making a necklace. Is it a permutation or combination?
Permutation.
It's a permutation. What type of permutation? Linear or circular?
Circular.
It should be circular because this is a necklace. And pay on that. Right. It's a circular permutation. Permutation but circular. And remember, for permutation of circular, we only take one scenario. That is, if you have n number of distinct elements and you take all n elements. So this is that kind of thing. We have 10 distinct elements because 10 different colors, and we are going to take all these 10 and going to create different circular permutations. Colors තියෙන විදිය වෙනස් කරනවා. නිලට පස්සේ රතු තියෙන එකේ අනිත් එකේ තියෙන නිලි රතු වෙන තැන් දෙකක. So therefore this is NPN question but circular. Because it's NPN circular, answer is factorial n minus 1. If it is linear, factorial n, NPN is factorial n, but this is circular. So therefore this is factorial n minus 1. So that means factorial 9. Okay, factorial 9. Do we have factorial 9? It looks like we don't have factorial 9, right? With 10 different. Okay, so therefore this is not answer because this is factorial 9 divided by 2. This can't be answer because this is not going to be factorial 9. Let's see whether this is going to be answer because we උත්තරය හරියටම ගන්න වෙනවා. That is factorial 10 divided by factorial 10 minus 9. That is factorial 1 divided by factorial 9. That is 10 because 10 and factorial 9. So this is 10. So therefore this is not answer for me. Then what about 10p9? 10p9 is factorial 10 divided by factorial 10 minus 9. Right? Factorial n divided by factorial n minus r. 10c9 එනකොට තව factorial r දිනුත් බෙදෙනවා මතකනේ. So this is factorial 10 divided by factorial 10 minus 9. That is 10 minus 9 is 1. That is factorial 10 divided by factorial 1 is factorial 10. Okay. But what we need is not factorial 10. What we need is factorial 9. So therefore I will not take this also because this is factorial 10. So then what about this? Okay. So this can't be right because, okay, let's see. This is np2, that is factorial n divided by factorial n minus r, that is factorial 7 divided by factorial 2. No, that can't be the answer also. Right? So it looks like none of these are correct for me. So this should be factorial 9. Double check the circular. Linear. Circular. Yeah, factorial n minus 1. So for me, none of these are answers. Okay. for me. Let's double check the answer. What the question? Yeah, 36, 2017, 36. 36. Or A and C. A and C. 2017, 36 A and C. ඉස්සර බලන්න මේ උත්තර දෙක සමානද කියලා උත්තර දෙකම සමානයි 10C6 10C4 because 10 minus 6
So
is
that is not the question.
sorry
2018 we did.
no this is sorry 2016
18, question number 34.
sorry
18.
2018 34 right sorry 2018 right I need to take the 2018 paper 2018 and answer question number 34 question number 34 answer is given as D right D let's see why 34 2018 34 so answer is given as E yes C so how can you get this factorial 9 divided by 2 because it should be factorial 9 right circular
Are we getting a double count here?
double
Double count in the circular.
Let's say something like A, B, C, D, E, F, E, H, 1, 2, 3, 4, 5, 6, 7, 8, I, J. So this is one arrangement. This is one arrangement. No, right? Why they have divided by 2? For example, if you have 3 colors, factorial 2. Factorial 2 is 2 because A, B, C, it is 1. Then B, A, C, that is another one because this is A, C, B. Right? So factor, that's all. That's all, right? Because there's no other way. If you arrange something, it will come into again this one of this. Okay, shall we put it into the chat GPT? Because still I feel like it should be factorial 9. Number of ways making a necklace using 10 bits with different colors. Okay. So shall we give it to the chat GPT and see? Because my answer is still factorial 9, not factorial 9 divided by 2. By the way, you are going to have some extra sessions next week also. Weekends, so weekday evenings, and also there are 2 holidays, Vesak Day and following Vesak Day, Monday and Tuesday. So I will be arranging 1 or 2 sessions there also. Okay, maybe 1 session there, so that we finish it quickly. Shall we ask ChatGPT because I'm a little bit feel like my answer should be correct. I can't upload. ChatGPT. It says factorial 9 divided by 2. Let's see. If the bits were arranged in line, it will be factorial 10, correct. Since it's circular arrangement, we divide by 10, giving factorial 9. That is correct, right? Circular arrangement, it is factorial 9 because factorial n minus 1. Okay. That is it. It's a circular arrangement. Since necklace can be flipped. Oh, necklace can be flipped. මේ මොකක්ද ඒ කිව්වේ? මට තේරෙන්නේ නැහැ. මාල ගැන දන්නේ නැහැ ඒක දන්නේ නැහැ. මොකක්ද ඒ කිව්වේ? Since the necklace can be also flipped, reflected, we divide by an additional factor of 2 to account for symmetry due to reflection. What is that? I don't know. බලන්න මාල දාන එක මේ මොනවද කියන්නේ කියලා? මම ජීවිතේට මාලයක් දාන්නේ. ජීවිතේට මාලයක් දාන්නේ නැද්ද? Fact. මොකද්ද මේ කියන්නේ? Necklace can be flipped or reflected. එතකොට මේක භාගයක් වෙනවා. In general factorial 9, but you take half of that.
So maybe flipping from left to right.
Sorry?
Maybe flipping from left to right.
So then you have half of the possibility. ඔයගොල්ලන් අහලා හරියන්නේ මම ChatGPT එකේ මාන්න. What you mean by reflected, flip, and why divide by is not clear. Flip mean in a necklace. Imagine you make a circular necklace with 10 colored beads and lay it flat on a table. Now imagine flips it over, like turning a coin over. Okay. The order of the beads is reversed. Okay. But you are still looking at the same necklace. Same necklace. Yes, same necklace. Counterclockwise. Every unique sequence has rotation, reflections, total linear divided by 10 to the... Okay, nothing comes to my mind, so just let's keep it open for the time being. Okay, so you guys can think about it. Maybe I also can think when I have some time. So now, of course, nothing comes to my mind. But what is this? Okay, but anyway, so according to ChatGPT, also you need to again divide by 2. Anyway, formula is correct, n minus 1, but now it says you need, because you can flip it, right? You need to make it divide by 2 again. That means you have only half of that. Okay? Anyway, just keep it open for the time being. Okay, right? So you can see it's a challenging question, right? Challenging question. Right, so this is an easy one. Right, do the 33rd question. This is the typical question. You know, the typical question. You know, දැක්ක ගමන් ඕන කෙනෙක්ට කරන්න පුළුවන්. දැන් ආයෙ අර vowels එකකට තියෙනවා. හරි? vowels තියෙනවාද පොඩ්ඩක් challenging දාන්න. දැක්කද? දැන් අර question එක කරපු එකට දැන් මේක කරන්න පුළුවන් වෙන්න ඕන. So all vowels in it are together. So therefore, it's a little bit challenging yet, but now you can take all the vowels as one letter. All the vowels as one letter, one block. But these vowels can be swapped. Vowels can be swapped individually among them, but all the vowels must be sitting together in all your words. Now this question is easy because we did a similar question. But definitely this is more challenging because you have the duplicates also now. Okay, you have duplicates, so therefore this is, you can see now you need to think extra. Anyone did it? This should be a doable question, but more challenging than the previous question. Previous question means the similar question we did about vowels. Right now, these are not distinct. And what are the vowels? O is a vowel, I is a vowel, E is a vowel. So therefore, we can take these 1, 2, 3, 4 letters together. This is my vowel block. Vowel block. Okay. Vowel block. So then we have other letters. C. Vowel, we have only once because vowel block has only one. C only once. M twice. T twice. Right? And inside vowel block, right? So now we have vowel block CMT. CMT and M twice, T twice. Inside the vowel blocks, we have O once, I once, and E twice. Right, now let's calculate how to arrange these things separately because that is easy. Now how to arrange these things, taking this as a block. Now we have 2, 2, 1, 1 because this is taken as one block. That is N is, big N is 2, 2, 1, 1, 2, 2, 4, 5, 6. We have N non-distinct elements. Out of those, N1 that is 2, N2 that is 2 because N3, N4 are 1, 1. Okay, so that means we have two similar elements because we have two T's, two M's. So therefore, if you have n number of non-distinct elements, and if you take all n elements, how many ways we can arrange? That is factorial n, that is factorial 6 divided by factorial n1 because we have two m's, and factorial n2 again factorial 2 because anyway this is factorial 1, this is factorial 1, factorial 1 is 1. That is factorial 6 because we took it as one block. 2, 2, 1, 1, 6 divided by 2m's, 2t's, factorial 2, factorial 2. That is arrange taking this as a block. Now, when for each arrangement, we can rearrange these guys inside this block. So that is where you have your capital N, which is 4. But out of that, 2 are the same. So how many ways we can arrange these 4? Factorial 4 divided by factorial 2. Factorial 4 divided by factorial 2. For each permutation, we can change this. So therefore, we need to multiply. So this is my final answer. This is my final answer. That is factorial 6 into factorial 4 divided by factorial 2, factorial 2, factorial 2. This is my answer. So make a very way. No, this is not answer. This is not answer. What is this? Factorial 9, factorial 4. Factorial, sorry, this is factorial 9. This is not answer. මම හිතනවා මේක වෙන එකක් නැහැ කියලා. හැබැයි සුළු කරලා තමයි බලන්න ඕනේ මේ දෙක උත්තර සමාන වෙනවද කියලා. හරි. උත්තර සමාන කරන්න දෙයක් නැහැ. වෙලා තිබුණා මම සුළු කරලා බලනවා මේ දෙක සමානද කියලා උත්තර. But for the time being I will go for C. Right? 33 I will go for C. 2018 33 I will go for C. Yes, answer is C. ඇයි දැන රතු කරේ? හේතුවක් නම් දාලා නැහැ. හැබැයි රතු පාටින් තියෙන හැබැයි උත්තරේ නම් හරි. right? උත්තරේ හරි. So answer is C. Okay. Right. So it's an interesting question, right? Interesting question, but you break it into sub. So that is how you develop software also, right? Break it into small parts and tackle it. That is what problem solving. That is why you have the math subject because you are into the IT. Yes.
So can you explain the answer again?
So we took this as a one block, all the vowels. Is it clear? Because vowels must be staying
Okay.
together. So then we have two one C letter, M two letters, T two letters. So that means altogether we have 6 letters. Taking this
Yes.
block, we have 6 letters. Now it is non-distinct permutation question. When you have non-distinct permutation, that is, I think, our last, second one, third model. So then we have factorial n, which is factorial 6, because 2, 2, 1, 1 is 6, divided by n1, n2, same thing. So that is, we have 2, 2. So that is arranging vowels as a block. These are the number of possibilities. Is it clear?
How does the factorial 2 and factorial 2 are here?
Because that is our model. We discussed that. Here. This one. Taking all n elements out of, case. Yeah, non-distinct elements, right? So when you have n1 similar objects, n2 similar, n3 similar, it is factorial n divided by factorial n1, factorial n2, and so on. So you need to divide by these similar things. So remember, this is 2a's divided by factorial 2, 2b's divided by factorial 2. Now here, we have 2m's. So therefore, divide by factorial 2. 2t's.
Okay, sir.
Factorial 2. And then this one you need to say separately. They are again non-distinct, altogether 4. So therefore factorial 4, this is 2 similar elements are there, divide by and then you multiply, because for each this scenario, this number of sub-scenarios are there. Okay. Right.
Okay, sir.
Right. So we did some questions. You can do the last 3 years of questions and any number of questions you like. Right. So now we'll finish our topic. Now we have done the permutation and combination, permutation and combinations, but we need to do a small part, which usually they don't check in the exams, but it is in your syllabus. Okay. I think they have never ever asked a question on from this point onwards, but this has been there in your syllabus for last 10 years, and no question also. Okay. So therefore, don't take this very seriously, but I will do it because it take only about 5 minutes. Let me double check whether it's still in your syllabus. නෑ මට අයින් කළාද කියලාත් මතක නැහැ. මොකද ටීවී එකේ අහන්නේ නැහැ. ඊන questions කරන්න. මේක දැන් පාවිච්චි කරපු model එක. තියෙනවා මේකේ. binomial theorem, Pascal triangle, pigeonhole principle. මේකෙන් මලාට ප්‍රශ්නයක් අහලා නැහැ. හරි? මම හිතන්නේ මුළු ඉතිහාසෙම BIT වල අහලා නැහැ. ඒ වුණාට ඉතින් කරමු දාලා තියෙනවනේ. Right. So now we'll move on to binomial theorem. So now this has nothing to do with what we have discussed so far. This has nothing to do with permutation and combination. So they have add this because these also use this. Of course I can't say nothing to do with, but this is all here also we use this NCR concept. NCR concept. Okay, right. So binomial theorem means, for example, you know how to write a plus b squared. That is a squared plus 2ab plus b squared. And how do you find a plus b cube? There's a way to do that, right? A cube plus 3a squared b plus and blah, blah, blah. Right? A cube plus 3a squared b plus 3ab squared plus b cube. And similarly, you can write a plus b to the power 4, a plus b to the power 5, a plus b to the power 6, and so on. And when you write this, mathematicians, actually the Pascal, right? Remember we discussed about Pascaline, right? I think Pascal is a French mathematician or Scottish mathematician. So he saw a pattern, right? He saw a pattern so that we can write what is a plus b4, a plus b5, a plus b6, and so on. So what is that pattern? Okay. The pattern is your each term is like this. Each term is like this. N is your n, right? For example, say you want to find a plus b to the power 3, then n is 3. K goes from 0, 1, 2, 3. K goes from 0, 1, 2, 3 because n is 3. If, of course, if you are looking for a plus b to the power 4, your n is 4, K goes from 0 to 4. So this is how you get your algebraic part. So therefore, your when k is 0, because n is 3 here, so then a to the power n is, remember, n is 3. Initially, my k is 0. So that is, my first term is a to the power 3 minus 0 is 3. B to the power 0, B to the power 0 is 1. That is a cube. Okay. So the second term is, now k is 2, a to the power 3 minus, sorry, k is 1, 3 minus 1, b to the power 1, that is a squared b. So that is how you are getting the terms. Of course, when you have the cube, you get these terms. A cubic, a squared b, ab squared, b cubic. Okay. So that is how you get the terms. Now, if you are looking for a plus b to the power 4, you take n as 4. How do you get individual terms? First you take k equal 0, k equal 1, k equal 2, k equal 3, and k equal 4. Right? So that is how you get the algebraic terms. So then how do you get these constants? Because here 3 and 3, right? Here you get 2. So that is where Pascal found a pattern. Actually, this is where you had NCR. Okay. Pascal found a pattern. So we call it Pascal triangle. So this is called the Pascal triangle. මේක කවදාවත් අහලා නැහැ හොඳේ. ඔයගොල්ලෝ මේ නිකන් මොකක්ද දැනුමට කියන්නේ. So this is how the Pascal triangle is made. So you start with 1, then 1 1 මේක තමයි පටන් ගන්න. එතන ඉඳලා ලියන්න පුළුවන්. Always this is 1, this is 1. So then 1 plus 1 is 2. Here 1 plus 1 is 1 plus 2 is 3, 2 plus 1 is 3. දැන් ඉතුරු ටික ලියන්න පුළුවන් මට. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. ඊළඟ ලියන්න පුළුවන්. මේ ඊළඟ එක ඊළඟ ඕනෙ නේද? a plus b ගේ වර්ගය a plus b ගේ ඝනය වගේ වට මේව ඕනේ. යට යට ඕනේ. So therefore now you know how to write this algebraic expression, and you have a way to find the coefficients, these constants. Right? For example, this is 1 2 1. This is 1 3 3 1. You can see 1 1 3 3 1. Before that 1 2 1. Yes, it is 1 2 1. දැන් මොකද දිහා බලාගෙන යනවාට Pascal triangle එකයි අර expression එක බලාගෙන යනවාට a plus b ගේ 10 a plus b ගේ 50 ඕන එකක් ලියන්න පුළුවන්. But make sure you build the Pascal triangle, right? 1 plus 4 is 5 and so on. So that is how, so that is called binomial theorem, because using this Pascal triangle and this expression, you can write something like a plus b to the power 10, a plus b to the power 12 or whatever. So that is called binomial theorem. Okay. Anyway, they have not asked a single question in BIT history. Okay. But it doesn't mean that they won't ask a question, but anyway, I did it. Okay. මගේ වැඩේ මම කරා. Right. So the final subtopic is pigeonhole principle. මම හිතන්නේ pigeonhole principle එකනොත් අහලම නැද්ද කොහෙද? සමහර එකක් අහලා තියුණා වගේ මතකයි අතීතේ. And it's a crazily simple concept. Very simple concept. අපිට කිව්වට පස්සේ ඔයගොල්ලන්ට hina යන්න පුළුවන් මේ මොකක්ද යකෝ මේක අපිට principle එකක් විදිහට කිව්වේ කියලා. Right. So the pigeonhole principle says, right, if you have n pigeonholes, ඔයාගාව තියෙනනේ n pigeonholes. මේක පහයි කියලා. Say you have 5, so let's say we have 6 pigeonholes. Pigeonholes ට කියන්නේ මේ pigeon ලව දාන කූඩු. So if you have n pigeonholes, and if you have more than n pigeons, so So that means if you have 6 pigeonholes and if you have more than 6 pigeons, and you are going to put those pigeons into these holes, always at least one pigeonhole will have more than one pigeon. At least one pigeonhole will have more than one pigeon. ඒක හරි නේද? Say if you have n number of pigeonholes and n plus 1 or bigger than number of pigeons, and you are going to put your pigeons into pigeonholes, always at least one pigeonhole will have more than one pigeons. ඒක එහෙම වෙන්න බෑ. pigeonhole 6ක් තියෙනවා නම් සහ 7 දෙනෙක් ඉන්නවා නම් ඉතින් ඔය 7 දෙනා දාදී අනිවාර්යෙන් එකකට දෙන්නෙක්ව දාන්න වෙනවා. දෙකක් දෙන්නෙක් ඕන ඔක්කොමලා එකකට දාන්න පුළුවන්. නමුත් හැමදෙස්සෙම ආට එකක මොකක් හරි එකක හරි අඩු ගන්න දෙන්නෙක් ඉන්නවා. දෙන්නෙක් හරි වැඩි ගන්නක් ඉන්නවා. So that is called pigeonhole principle. Okay, pigeonhole principle. Okay. Is it clear? ඒක නම් clear නැහැ කියන්නේ කොල්ල කරන් ගහන්න වෙනවා හරි. So that is called pigeonhole principle. But this pigeonhole principle can be used in an interesting manner because those who know the pigeonhole principles, it's easy. But sometimes if you have not heard of pigeonhole principles, right, sometimes we can magic karna කියලා. So we can make some people sort of right, not fooled, right? So those who know the pigeonhole principle, maybe that statement is very straightforward. But if you don't know the pigeonhole principle, sometimes you might feel like, okay, how can that happen? Okay, right. I will give you some of those, maybe one or two of that kind of statement. For example, let's assume that, right? Now in this session, there are 23, okay, let's say 22 students. 22 students. Okay. If I tell you there's a guarantee that 2 of you guys must be born in the same day. Same day in the sense, say 1st, 2nd, 3rd, up to 31st. Can I say like that? My statement is, it is guaranteed that at least 2 of you have born in the same day of the month. Maybe you are 2nd January and the other guy is 2nd February, but 2nd is 2nd. Can I say like that? Yes or no? Can I confidently say like that? So my statement is guaranteed at least 2 of you guys have born in the same day of the month. Any month, but same day. Can I say like that confidently?
No.
No. Right? So in what kind of a scenario can I say like that? Confidently. Because you guys, there are only 22 students. But if you have more than 31 students, even 31 I can't say. But if this session has 32 students, I can confidently say, guaranteed, at least 2 of you guys are having the same date. Date means born in the same day of a particular month. So that is according to pigeonhole principle. Right? Pigeonhole principle. And if I have more than 365 students, say 366 or above, I can very confidently say, at least 2 of you guys have the same date of birth. ඔයගොල්ලෝ අතර අඩුම ගානේ දෙන්නෙක් එකම දවසේ ඉපදිච්ච අය ඉන්නවා. ඒක එකපාරට කාට හරි හිතන්න කියලා එහෙම කොහොමද වෙන්නේ? But according to pigeonhole principle, that is the case. But if you have less than 365 also, there's a possibility, but there's no guarantee. But the moment number of students are more than 365, guaranteed that at least 2 students are born in the same day. So that is what, those are some practical usages of pigeonhole principle. Okay. So these are some interesting statement from pigeonhole principle. Okay. So we can demonstrate there must be at least 2 people in London with the same number of hair on their heads. අපිට guarantee එකක් කියලා කියන්න පුළුවන් ලන්ඩන් නගරේ ඉන්න අඩුම ගානේ දෙන්නෙක් ඉන්නවා එකම කොණ්ඩ ප්‍රමාණයක් තියෙනවා. එකම කොණ්ඩ ප්‍රමාණය කියන්නේ කොණ්ඩ ගස් ප්‍රමාණය සමාන වෙනවා. එහෙම කියන්න පුළුවන් කොහමද? So typical human's head has around 150,000 hairs. සාමාන්‍ය මිනිසෙක් එක්ක තියනවලු උපරිම 1,50,000. ලන්ඩන් නුවර ඉන්නවනම් 1,50,000ට වඩා සෙනග අනිවාර්යෙන් උතන දෙන්නෙක් ඉන්න පුළුවන් එකම ප්‍රමාණයක්. හැබැයි 1,50,000 අඩුව තියෙන නගරයකට ගිහින් ඕක කියන්න බෑ. So some consequences, okay? Right, so that's it. Anyway, they have not asked any question from that, but anyway, I just did it. Right, so we'll take a break. After the break, we'll move on to database. Okay, so let's continue. Right, so let's move on to SQL. Okay, SQL. So that is our last big topic for web development. Database. Okay, SQL. So then we have the data security and views. Then we are done. Let me close this. Right, SQL. So SQL stands for Structured Query Language, and SQL is the standard language that we use, either humans or applications, to communicate with the database. So we can do almost all the things that we need to do with database using SQL, right? SQL. So that means as humans, we can write SQL and execute, and programs also, like your web application, PHP code, your JSP, your Java, C#, applications can send SQL statements to the database, and database can either do it, like insert or update, or give you the results like a select query. So it's a good thing that at the very early days of IT software development field, so American National Standard Institute standardized this language. So therefore, whether you are using Oracle or MySQL or Microsoft SQL, you can write the same SQL. Because all the major database vendors support SQL, relational database vendors. Okay? Which is a good thing, because otherwise we would have to learn different ways of communicating with different databases. And when it comes to SQL, yes, SQL is a standard, but it doesn't mean that all the databases follow 100% the standard, maybe more than 90%. For example, some databases may not support some of the advanced SQL statements. And at the same time, some of the databases may support additional SQL statements, which is not standard SQL. But that is very minimal. Okay, so therefore, when you port an application from, say, MySQL to Oracle, you may need to do small changes, but majority of the things you don't need to change. Not only the database structure, even our programming codes. Okay, because majority of the databases support the majority of SQL. Right. Right. So how do you work with SQL? You need to connect to the database. Now, remember, so far we have been working with access, right? Access for designing and everything. But from today onwards, we will be using MySQL. And of course, we have been using MySQL in semester 1 also, from semester 1 time, right? Remember, we discussed how to connect to database using Java, using JDBC. There also we use MySQL. And also in next semester you have PHP, which is server-side scripting. So therefore, I ask you to download and install either SAMP or WAMP in semester 1 itself, because SAMP server has MySQL and also Apache Web Server configured with PHP, because we need PHP in the next semester. So how to download and install, I explained in semester 1 itself. I don't mind which one you are having, or even if you have pure MySQL, that is also fine, right? Right. So if you are interested in installing SAM, just go to search SAM, go to Apache Friends website and download the relevant version. Just double click and install. Right. So usually you should be able to install SAM without any issue. But if you get any issue and if you can't resolve it, sometimes they will ask you to, or your installation sometimes will ask you to download and install a .NET update. So then you can search for that and download and install from Microsoft site. So usually that is the possible error you get and you how to fix it. But more than 99% of the time, you should be able to install SAM without issue. But in case you get issue and you have no other option, then you can try WAMP. Like WAMP, because WAMP is also similar to SAM. It has again Apache with PHP and MySQL and few other software, okay, or any other bundle, right? As long as your MySQL is running, that is fine. Right. I have installed SAM. You can, after installing, you can search for SAM. Get the SAM control panel. And initially, obviously, your servers will be down like this. So then make sure you start Apache server and MySQL server. Both must be green and no red code here. No red logs here. Now my Apache server is up and running, port 80. Now my MySQL server is also up and running because it's green. If it is red or yellow, there are issues. Then look at the error messages and fix it. Okay, fix it. Or you can paste that screenshot into what's ChatGPT. Right. So my Apache web server is running. Why I'm running Apache web server? Because then from web interface I can connect to MySQL, which is easier rather than working with command lines. Okay. So when you install SAM, MySQL is installed inside SAM. For example, I have installed my SAM in my C drive. Again, if you want any other software, that is fine, right? In my case, I use SAM. So inside SAM, this is my SAMP installation folder. There's a folder called where is my MySQL? Yes, MySQL. And this is where MySQL is installing if you are using SAMP, okay? Right. And we are interested in this bin folder. If you are connecting to the MySQL database using command line, make sure you add this bin folder to your path variable so that you can run MySQL commands. Just copy the path. You know how to do that because we did that kind of things in Java also, semester 1. Go to settings and search for environmental variables, preferably system environment variable, and go to environment variables, go to path, preferably your system path, and edit and add an entry to your bin folder. Of course, I already have it, so therefore I'm not going to change it, and say OK. Okay, so that is the only thing you need to do. Sometimes your installation will do that also, right? So first of all, you can take a command line, and then you can type MySQL. Okay, and if it gives you a response like access denied, so that means you have set up your MySQL proper, and of course make sure that your MySQL is up and running. Right, it's green, it's up and running here. Okay. So then if you get this kind of a message like access denied, that is fine. That means you have added your bin folder to the path, or your installation has have added. if you get an error saying MySQL is not recognized as a command, then only you can go and add that path variable, bin folder to the path variable, then take another command line and again type MySQL. Then you should get this kind of error because this is because I have not given the username and password. And also when you install MySQL, by default, a user is created called root ROOT with password blank. Blank means nothing. Nothing. So therefore, you can use that built-in user to log into the MySQL. So how to do that? MySQL, assume that you have the path variable set up. Okay. MySQL, space minus u space root. Of course, if you have the password, you need to say -p and without space password. But by default, when you freshly install MySQL, the username root or the admin user doesn't have a password. So therefore, you can just enter. Now you can see you are in MySQL. This is not DOS prompt. This is MySQL or the MariaDB prompt. Okay. Right. So then you can connect to your database or create databases and do anything you want in the command line. Okay. In the command line. And there's another thing. There are two versions of MySQL. Right. One is MySQL, which is from Oracle. Right. So this is the original MySQL. Okay. The second one is MariaDB. MariaDB. MariaDB is the free and open source version of MySQL. Okay, so if you install SAM, what you get is this MariaDB. So MariaDB is fine for us because MariaDB is the open source version of MySQL. So that is why I got this prompt saying MariaDB. That is fine because that is a free and open source version of MySQL. Okay. But if you install something else like WAMP, I think maybe you are getting the MySQL. Okay. Because MySQL also has a free version, but not a 100% free and open source version. And we will be using SAM. Therefore, we will be connecting to MariaDB, which is the free and open source version of MySQL. Okay. So that is how do you start with database. The second approach is without going to the command line, but it's always good to familiarize with a little bit of command line. That is good for your confidence. So the second approach is if you have started both Apache and MySQL. So this work even when you have only start MySQL without Apache because this command line. But if you have start up both Apache and MySQL and both are running, you can go to this admin. You can go to this admin, make sure both are now running. Right? Go to admin. It will open a web browser. Right? Web browser. So the URL is local/phpMyAdmin. If you can remember the path, you can just type it also. local/phpMyAdmin. So just be a little bit patient. It will take a bit of time to access it first time. And this is what you get. This is what you get. So using this browser also, this is the phpMyAdmin console. That is why I started web browser, sorry, Apache web server. So let me just give me 1 minute. I want to make this window smaller. Why can't I make it smaller? Unlink from main panel. Collapse all. Is it unlink? Yes, now I can do it. Right. So initially, you will not have this number of databases, maybe just one database called system or something, or MySQL. So these are the databases I have created. So from here, you can create a database. Right? So that now you have two options. You come to the PHP and do all the work. Second option, you do all your work using the command line. Now you have connected to database. So I recommend you to familiar with both, but once you're familiar with command line, you can just forget about the command line, but first familiar with command line, and then you can use PHP because it's much more faster and easier UI interface is there. But it doesn't mean that you must not familiar with command line. Okay? Right. So therefore, I will first explain little bit of MySQL command. These are not SQL, right? Because maybe you are interested in connecting to database using command line. So now this is not a MySQL command. This is how you connect MySQL space -u space username. In my case, I connected using the default admin user rule because password is blank. You don't need to type anything. But if your root account has a password, you need to say -p without space the password. Okay. Now this is not DOS prompt. This is my MariaDB or MySQL prompt. So there you can type some MySQL commands. So MySQL commands are not tested in your exam, but MySQL commands are required if you are working with MySQL in command line, which is sort of a expected skill from anyone who is doing IT. Right? IT කරන ඕන කෙනෙක්ගෙන් බලාපොරොත්තු වෙන MySQL වලට command line එකේ connect වෙලා වැඩක් කරගන්න පුළුවන් කියලා. හරි? දැන් නැත්තම් නිකන් උපාධි සාතිකයක් විතරයි. Right. So if you want to see what are the currently available databases that or currently created databases, there's a MySQL command called show databases. Show databases. Every MySQL command ends with semicolon. It's like English. Show databases and enter. So not show databases. Show. Is it show DBs? Anyone can remember what is the exact show? I think I made a spelling mistake. Show, yeah, BA bases, right? Show databases. It's not SQL. It's MySQL command. Okay, MySQL command. So it will show you the database. Of course, when you freshly install MySQL or MariaDB, you will get maybe just one table, system table, right? But anytime if you want to check what are the available databases or already created databases, just type show databases. Okay. And when you create a database, that database will also get into this list. Okay. Right. So remember now you have connected to the MariaDB or the MySQL, but still you are not connected to a database. Of course, if you have a fresh MySQL installation, you don't have any database also. Right. So let's see how to create a database. It's very easy. This is still we are not doing SQL. We are doing MySQL. Okay. So these command can be different from MySQL to Oracle, Oracle to Microsoft SQL. Right. So this is how you create a database in MySQL. Create database and your database name. Right. I'll call it S225. Semester 225. Okay. Right. I forget the semicolon. Therefore, now I can type the semicolon. That is fine. So make sure you have semicolon because until you type semicolon, you will get this prompt. Right. And it's a query OK. Right. Query OK means database is created with the name S225. Now, if I type show databases, your commands are in your up and down the keys. And now your S225 must be there. Yes, that is our newly created database. Okay. Now, if I refresh here, because earlier S225 was not there. Now, if I refresh, that database should also be displayed. You can see, because we are looking at the same database. This is web interface. This is command line. Okay. Right. Still, you have not connected to this database. You have connected to MySQL. If you want to connect to this particular database or any other database, you have MySQL command called use. Use your database name. In our case, S225, semester 225. And remember the semicolon. And now it says database change. So that means now I am connected to my newly created database. Now, if you create tables or if you run a SQL statement, all your statements are run against the database you have selected. At any time, you can change your database. For example, I can say use, say A-level ICT 2025. Okay, I think I made a mistake. A-level, yeah, ICT 2025. So database change. So now I am in the A-level ICT 2025 database. Okay, so I connected to that because it has some tables. Now, if you want to see what are the tables in your database, that now I have created connected to A-level ICT 2025 database, you can type show tables, just like English, show tables. It shows what are the available tables. In my case, there are two tables called employee and department. So these are all MySQL commands. Then, of course, you can start writing your SQL. For example, if I want to query all the data in my employee table, I can write select. This is SQL now. All from, say, employee. And it shows the data. So now you can start writing SQL. If you want to create a table, create statement. If you want to drop a table, drop. Now you can start writing SQL. So far what we discussed was MySQL commands. Okay. Right. At any time you can change your database, because now I am in A-level ICT 25. So therefore I'll change back to S225. How to do that? Use S225 database change. Now, if I type show tables, obviously it will say nothing because I have not created any tables. Right? Empty. Right. So that is how you work with. Now you can write all your SQL commands here. Okay. Make sure you are connected to the correct database using the use command. Okay. Right. We'll come back to this later. And from here also you can do all these things. So if you want to create a new database, you can click on new and give your database a name. Okay. I'll call it, say, Nalaka temp. So don't worry about this character set, just use whatever the default and say create. And you can see there's a database called Nalaka temp. And of course, I can go and create tables. Table name, let's say employee. How many columns? You can change the number of columns anytime. So then you give the column name, say employee ID, and so on. Okay, say name, say it's a Vacha 20, maybe salary, maybe float. I want to mark employee ID as my primary key. There's a Index must be primary. Go. And auto increment if you want to make it auto increment. And then you can say either you can see preview SQL, that is the SQL that is generated by your tool, or you can write this SQL later, create table SQL, or you can just say save. That means your table is created now. Now you can see inside Nalaka temp, there's a table called employee. Or you can use SQL prompt to write your SQL statement, or you can go to the SQL prompt and create your tables and everything using SQL. And here you can just execute it. Okay, go. Right. So do you have any questions? Any questions? Right. So I'll be using bit of command line and bit of this. And after sometimes I will be using only this. Okay. Right. Now we can start doing SQL. Okay. SQL. Right. We can classify SQL statements. Of course, SQL is SQL. This is just for our convenience. Some SQL statements we can put it into DDL. Some statements we can say, okay, those are DML statements. Okay, so this is just for our convenience we classify. Some SQL statements are called DDL or data definition language SQL statements. So that means you define your structures like tables, relationships. So that includes create statement, alter statements, drop and truncate. Okay. So those are to create a table, alter the structure of a table like add another column, drop a table, drop a column, drop a primary key, truncate all your data. So then we have DML SQL statements. That is
What is meant by truncate?
yeah, truncate we will discuss later because we take that statement separately. Okay, truncate means basically you drop the table and recreate the table. So that effectively it will delete all your data. But actually you are not deleting, you drop the table and create the table. So that is another way of deleting your data. Right. So then data manipulation language statements include insert, delete, and update. So you insert a record, you update existing record or set of records, or you delete one or more records. So if you are writing this kind of statement, insert, delete, or update, you are writing one of the DML statements. So the third category is data query language or DQL. And this is the most widely used type of a SQL statement in programming. That is select. That is you retrieve data based on some conditions and so on. So the fourth category is data control language, which we look at in your next topic, that is security. It's all about security related things, right? Authentication, authorization, grant, revoke, and so on. So the fifth category is data control language, which we don't discuss in semester 2, but you will be discussing these things in semester 3, because semester 3 you have data management system. So the part 2 of the databases, there only you will learn about transactions, and you will be doing these things in heavy level in next semester. But here we only look at these 4: DDL, DML, DQL, and DCL. We don't look at TCL. TCL is for the next semester. And ability to write a SQL statement is a very critical capability or competency. And it's not difficult. It's not at all difficult to write a simple SQL statement, but unless you are very serious, you will not be able to write very complex or sophisticated SQL statements. Sometimes you need to write some complex statements to get your requirements fulfilled, like getting data for your forms, getting data for your reports, and so on. So therefore, this is a critical skill, right? Especially when you are doing final year project. If you are not good at SQL, you will be completely stuck. because you don't know how to join two tables. You don't know how to write a subquery. So therefore, this is serious stuff. And in the exams, although examiner asks very tough questions, because examiner want to make sure that only serious people go into the next level. Okay. Right. So we'll start with DDL statement, simply because without creating some tables and so on, we don't have anything to play with. So therefore, naturally, we will start with DDL statements. That is create, alter, drop, truncate. Create, drop, alter, truncate. So some people consider truncate as a DML also, but most of the books classify it as a DDL. Okay. Right. So let's start with create. So create statements. So we use capital just to highlight it. Okay. So you can write simple. There's no issue. Right? Simple, low, capital, low, mix it because SQL statements are not case sensitive, like Java and so on. Java is case sensitive, right? Python is case sensitive, but not SQL. But most of the software developers prefer to write SQL in capital just to highlight it because we don't write much of SQL. Usually, we don't recommend you to write your HTML in capital because we write a lot of HTML, but we write only small amount of SQL in software. So therefore, software developers prefer to write it in capital so that you can highlight that it's a SQL state. Okay. So therefore, anyway, because I also got used to it, I will also be mostly writing SQL in capital, though it's a little bit of more effort. Right. We can use create statements to create tables, which includes creating fields, primary keys, and any other constraints. And also we can create relationships using foreign keys. And also we can create indexes. So basically anything that you create, you use create statement. So these are the things that you create in a database. Okay. So this is the basic structure of a create table statement. Create table, your table name, within brackets, you write your column name, its data type, and optionally if you have any constraints, like not null, unique, primary key. So you can have any number of fields. Make sure that for the last one, you don't have the comma, but all the others you have the comma. Comma separates your fields. But last one, if you must not have comma, if you have comma, you will get error. Syntax error. Right. So this is a very simple statement to create a table. Create table, your table name, ID is your first field, data type is in name, varchar 50. If you are using varchar data type, make sure you give the size. For other data types, size is optional, but for this, it's sort of a mandatory. And location also we use varchar because this is the last field, no commas. So this is how you create a table. No primary key, nothing, simple table. So let's create a table. I will take it to a notepad because I will share the code at the end as well. I think it is not properly copied. Yeah, it is not getting copied, unfortunately. So therefore, I need to copy this separately. I'm lazy, that is why I'm not typing. Right. Okay, let me type it. Create table department, ID, say int, comma, I have a space. Say name, Vacha, say Vacha 20, that is width is 20. And maybe location. I'll say again Vacha, say again 20. And because this is my last field, I will not have any commas. And this is my create table. Of course, if you want these things also, you can make capital, but I just make it simple, okay? So now I can take to my command line because I have connected to S225. I paste it, right click, paste anyway. Make sure you have the semicolon and enter. If it says query okay, that means no issue. Otherwise, it will give you the error message. Now I have created my first table. Now if I type show tables, which is not SQL, this is MySQL command show tables. Now you can see there's a table called department. And from your web interface also, remember it is A-level ICT 20, sorry, S225. You can see there's a table called department because I created prop command line because we are connected to the same table. Only thing is maybe you need to refresh this. And this is the structure. Okay. That is how you create a table. And if you want to drop a table, it's very easy. You just type drop. So this is DDL. Under that create. So this is drop. So drop is the easiest SQL statement. It's very easy. Drop table because I'm going to drop the table and your table name. In my case, department. Very okay. Now if I type show tables, no empty set. That is no tables because you have dropped the table. Drop means if you have data is also deleted, the table is also no longer there. Okay. Right. So that is you just created the table without any constraint, primary keys, nothing, right? So remember, whenever you create a table for each and every data field, you need to give the data type. And American National Standard Institute has standardized the data types. Giving these are the standard data types like chow, character. But unfortunately, vendors use so many other different types. Actually, not unfortunately, because vendors want to support more and more types. NC has given only basic types. So therefore, from MySQL to Oracle, Oracle to Microsoft SQL, you may see some of the fields are maybe name is different, maybe you have additional types. Okay. So that is to make your life easier as a software developer. So therefore, don't take it as a negative thing. But in your exams, because your exam is more related to the MySQL, it will refer to just the basic MySQL types like Vacha, float, date, text, and so on. Like just about 4-5 very commonly used data types only we will refer because our task is not learning MySQL or Oracle. Our task is learning SQL. Okay, concepts. Okay, right. So the other thing is whenever you use Vacha, that is variable character, you must give the width, maximum width. But for other data types, usually you don't need, it's a optional, but this is sort of a must. Okay? Within the bracket, that is the maximum width. Right. Right. So now we want to create a table with a little bit more seriousness. So remember, a very important concept in table is primary key. Some databases even do not allow you to create a table without primary key, but MySQL allow at least. So this is how you say it is your primary key. There are three ways you can specify primary key. This is the approach one. In your field, after giving your data type, you say not null and primary key, because by default, primary keys must be not null. Right? Primary key field must not be allowed. You must not allow null values for primary key. So therefore, make sure every time you create primary key, it's a not null field, and then it's a primary key. Okay. So this is the first way. Right? Okay, whenever I copy paste, I don't get part of it, right? Right. So I can copy paste this one itself. Create table department ID int not null and primary key. This is approach number one. I can run this because I have dropped the table. Okay. මම පුළුවන් තරම් command line එකේ ඉන්නවද? හැබැයි ඊළඟ දවසේදී ගොඩක් අයට අපි යනවා web interface එකට. හරි? Semicolon. Right. So now I have created the table. Again, if I type show tables, මම ටිකක් MySQL commands ටිකුත් මේ ASCII කරනවා. හරි? Sorry, show tables, two words. Department. Now, if you want to see the structure of the table, this again MySQL command, you can type des for describe. Des is the shorter version, des, and table name, department. Now you can see the structure, ID, int, දැකලා අපි 11 කියලා දැම්මලා දෙනකොට එයා default value එකක් ගත්තා. අපි මේව අපි දානවා. And you can see my ID is a primary key. Primary key, and null is not allowed. Null is not allowed because I specify that it is not null field. Other fields null allowed. You can see null, yes. But this is primary key and not null. Null values are not allowed. And default is null because we have not given a default value. Right. So let's look at the second way of creating a primary key. So this is, you set it there. Second way is you just specify the column and later you say this is my primary key, your field name. Okay, so that's the second approach. So let's drop it first. Drop table department, and now I will recreate it. The second approach of creating primary key, okay? So now I will say this is just not null, and this is not my last line now. And now I can say primary key is ID. Primary key ID. And now this is my last line, so no comma here. So this is my second way of creating table with a primary key. Right. So there's a third way. Third way. So third way is okay. Before going to the third way, there are situations where you can have multiple or composite primary keys. Remember connecting tables and so on. So if you have a composite primary key, you can't use the first approach. Right? You can't. Okay. Sorry for that. You can't use first approach because you can't have primary key keyword in two fields. So then you must go for the either second approach or third approach. Second approach, if you have two fields and if you want to make this combination as primary key, that is also possible. Okay, that is additional note. How to create composite primary keys. So you must use either second approach or third approach. Right. So the third approach is, so let me drop the primary key table again. Right. So in third approach, again we create the primary key, but this time we can give it a name. So we can say constraint and give it a name. Usually we give the name pk underscore the table name to primary keys. That is not a must, just a best practice. Say pk department. Don't worry because this is just name. And then you say primary key, what is your primary key? Or it can be a composite key like comma separator. So that is the third approach. The third approach. So in this case, we have given the primary key a name, constraint name. So therefore, if you want to drop the primary key, you can use drop primary key as well as you can say drop this constraint. Drop this constraint. So therefore, giving a name is better approach than just create the primary key. But anyway, both approaches work. All these approaches are valid. Right. So those are the three ways you can create a primary key. Right. This way, or create it as a constraint. And composite primary keys also you can create using constraint. Okay. Right. So we'll stop at this point. Next class, we will look at how to create relationships, how to alter your table, right? Drop we have done. So then we'll move on to data manipulation like insert, update, delete. That won't take much time, but select statement will take a lot of time because there are so many variations. And remember, you are going to learn A to Z of SQL. Nothing to learn after semester 2. software industry එකේ ඇමරිකාවේ හරි කොහේ හරි ගිහිල්ලා වැඩ කරන්න අවශ්‍ය SQL ටිකක් කරලා ඉවර කරන්න. හරි? ආයි SQL ඉගෙන ගන්න ඉතුරු වෙන්නේ නැහැ. හරි? SQL ඉගෙන ගන්න ඉතුරු වෙන්නේ නැහැ. A to Z කරලා තමයි සිලබස් එක තියෙන්නේ. හරි? A to Z. ඔයගොල්ලෝ සිලබස් එකේ නේ මොන සිලබස් එකේ වුණත් සබ්ජෙක්ට් එක ඉවරටම ඉවර කරනවා SQL. හරි? Right. So we stop at this point, right? Thank you.